this neuron is the starting point of that. So initially development starts from the McLapid neuron. And if you look at the McLapid neuron, so the McLapid neuron, you can see we have two parts of the neuron where we have inputs from x1 to xn, and those inputs are binary in nature, 0 1, 0 1. And you can see we have two functions, two part of this neuron, where is one part is simply an aggregator. So I is equal to 1 to n and summation xi. And the other part is a activation function. So if you look at this activation function, this is a simply step function. If you can see, because most of you must be from mathematical background, so you can easily understand if this aggregation is greater than equal theta, then the output of this neuron will be 1, and if this aggregation is less than theta, then the output of the neuron will be 0. So output of a neuron is 1 and output of a neuron is 0. That means neuron is activated or not activated. So this is the simple concept behind McLapid neuron, and theta here we call it as a thresholding function, thresholding value 0. So output of a neuron, when we move further, 1 and output of a neuron is 0. That means neuron is of a McLapid neuron. Then the development starts and people started solving problems. So initially this McLapid neuron was used to solve the binary classification problems, and initially it was used for the simple logic gates. You can see we have AND gate, OR gate, and if you look at okay. So if you look at the second figure where we have AND function, and in AND function we have three inputs x1, x2, and x3, and you have seen that 3 is written over there. So if you correlate this x1, x2, x3 with 3, you can see summation xi I is equal to 1 to n. So this will give you 3. And the condition says if this product is greater than equal theta, you will get a 1. And in a Boolean AND gate, if all the inputs are 1, then only you will be getting a output 1. That's why this threshold value is 3 in case of AND function. Similarly, the OR function, where the OR function says if any one of my input is 1, I will get a 1 as an output. So the threshold is 1 over there. Similarly, and the x1 and not of x2, here this is the inhibitory input. That means the input is inverted here. So here 1 is written as the threshold, but this 1 is not correct. So can anyone suggest what should be the thresholding value in order to get an output x1 and not of x2 from this neuron, from the students? What should be the thresholding value? So it should only give you 1 when x1 is 1 and x2 is 0, because this is ending in between. So what should be the thresholding value? For other part, it should give you 0. So this threshold should be other than this. Then next, NOR function. Again, look at the NOR function. The inputs are inverted. Thresholding is 0, but that is wrong. What should be the input over there? So threshold should change over there. Then the NOT function. So if you look at the McLapid neuron, all the inputs are 0 or 1, and all the inputs, they are equally weighted. That means the importance of all the inputs to the McLapid neuron is same. We are not distinguishing them. Now, this is again the detailed function of the OR or function you can look at, like we can represent this in a two-dimensional plane, and where we can see the classification boundary. If you look, you can see in the diagram, the classification boundary says if x1 plus x2 is equal to theta is equal to 1. This is the line of equation of a line. So all the points which are lying on this line or above the line, they will be class 1, and all the points which are lying below the line, they will be in class 0. So this acts as a binary classifier. You can see the OR function for 0 0, the output is 0, and for other three inputs 0 1 1 0 and 1 1, the output is 1. So it is actually acting as a binary classifier. But here in this case, what the requirement is, we have to assign the thresholding value. Thresholding value is to be assigned by the user. You have to decide what should be the thresholding value for this McLaughlin neuron to act as a OR gate. Similarly, the end, you can see the thresholding value has changed, and the classification boundary line, that is also changed. It is shifted because this will give you 1 for the input 1 and 1 only. For others, the output will be 0. That means 0 0 0 1 and 1 0. The output will be 0. See, all the points which are lying on the boundary classification line and above, they will be part of one class, and others will be part of another class. And again, the same thing, you have to assign the thresholding value. The third one case, it is a tautology case, means it will be giving you output always 1, because here the thresholding value is 0. So whether you give 0 0 as an input, then also you will be getting output 1. Why 1? Because your step function says, the condition says summation xi I is equal to 1 to n greater than equal 0. You will be getting a output 1. So because of that equation, you will be getting all ones, and all the points are on the one side of the classification boundary. This is for 3 input gate. So when you have 2 input gate, 2 inputs, the classification boundary was a single line. If the number of inputs are increased, accordingly the classification boundary will change. So here the classification boundary will be a plane. Yes? So now, but in real life, do you feel the inputs like 0 and 1, they really exist? No. In real life, we have real in. So that means we must think of some alternate. So after that, this perceptron was developed by Frank Rosenberg in 1958. And if you look at the diagram, we have inputs from x1 to xn, and the weights are assigned. So this is the real life scenario. That means all the inputs are not likely. We may give importance to one feature, we may give importance to another feature. So depending upon the importance of a feature, similarly weight can be given to features. So then it will give you a weighted sum. Weighted sum. That is the real life scenario. But in the McLaughlin neuron also, if you look at the thresholding function, here also we have a step function as the threshold value. So look at the equation on the right hand side. This is same as we have seen in case of McLaughlin neuron, except one difference. And difference is, you can see it's a weighted sum, WIXI. Rest is same. And one more difference, if you look at the bottom left, this theta is now, theta means the threshold. It is now part of the function itself, and value of theta is minus. So this minus value, if you look at this minus value and look at that function, summation WIXI minus theta greater than equal 0. If this is equivalent to this one only. Only thing is, where here the inputs were from I is equal to 1 to n, Here inputs are from I equal to 0 to n. And value of theta is, weight is minus theta. And the input is always 1. So this is incorporated in the equation itself. And again, the output will be 1 if this value is greater than equal 0, or output is 0 if this value is less than 0. So this simple functionality is also used as a binary classifier in case of many artificial neural network applications. Wherever we have a binary classification problem, data is linearly separable, we can use a perceptron. Let us move forward. Now the question is, why we are trying to implement Boolean functions. So we have seen the Boolean functions linear, wherever we have an application of linearly separable data. Boolean function means output is 0 or 1. So we can use it. Number 2, why we need weights? Because in some of the real life applications, we need to give weights to the features. Some of the features are more important, some of the features are less important. Accordingly, you can give them weights to show their importance. Third one is why W naught is equal to minus theta, and it is called as a bias. So it was a threshold. So why this threshold is required at all? So we need to answer these questions in the upcoming slide. Now look at this example. It is a real life scenario. If you look at, so the MATLAB, this is a perceptron model. We have three inputs, x1, x2 and x3, and x1 input is actor, name is someone, x2 genre, x3 director. So these are the three inputs, the actor name, the genre name and the director name, and the threshold x0 is 1. Now look at, you want to predict whether you would like to see a movie or not. Find the classification problem from the real life scenarios. And suppose you have your past experience, data you have taken, and you have given a high weight to the director. Look at this compared to the other inputs. Now, in the next example, look at, if as a student we are only interested in, okay, let's go for the movie. Movie देखने जाना है बस, without looking into who is director, who is actor, what is the genre, बस time pass करने के लिए जाना है. Yes or no? So in that case, value of theta can be 0. That bias threshold, we have to go for movie. In that case, the weight, all these three weights can be 0. So what will be the output of the summation function and the activation function? 0. But your activation function says if it is greater than equal 0 itself, then the output will be 1. That means we'll go to see a movie. So when the means your decision is not dependent on the importance of the input features, threshold is 0. In the other case is what it says, a selective viewer will only go to see a movie that is thriller. The director is Nolan and the actor is Damon. Then only you will be going to see that movie. That means importance to all the features. So when your neuron will give you 1 when the sum total will be greater than equal 3. That's why the theta is taken as 3. If the theta is 2, then the neuron will give you output for any 2 inputs also. Means it will ignore the third feature. But here we want to see all the features. the importance of all the three features. That's why this theta is taken as 3. So this is the importance of taking weight in case of a perceptron, and this let down the basic requirements of the artificial neural network architectures. Now moving further, what kind of functions can be implemented using a perceptron? So we have seen a McLaughlin neuron and we have seen a perceptron also. Then what is the difference between the two? So difference you have seen. What was the difference? A McLaughlin neuron inputs are binary. Inputs are binary. All inputs are of equal importance. Equal importance. Perceptron model. The inputs can be real valued also, and we can give weight to inputs. This is the difference between both the models. But yes, their applications are almost same. Means both McLaughlin neuron and the perceptron model both can be used as a linear classifier. Linear classifier. Linear classifier, I hope all of you are aware of, right? Where data is linearly separable. Now, look at this again, a real life example where number of features are very large. So till now we have seen two, three input features, but in real life there can be n number of features. And accordingly we have take a decision. Problem remains the same, a linear classifier only, but the number of features have increased. ये वापस yes. So now the thing is, when the number of features have increased, then how to learn these weights? In the earlier case, because the number of features were very less, we were manually deciding the weight. We were manually assigning the bias. But in real life scenarios, it is not possible. So what you need? We need something that can automatically do this. Algorithmically, that can do that. So the perceptual learning algorithm. So in real life scenarios, we need some algorithmic way of providing the weights to the inputs, importance to the inputs, because you cannot decide in real life scenarios. So this is the perceptual learning algorithm, and this is the basic design that again laid down the learning algorithm for deeper neural network architecture. So if you look at, try to understand this. So we have two types of inputs. One is the positive points, other one is the negative point. You can say positive point means which are lying on the one side of the line, and the other points are which are lying on the other side of the line. Right? Now what the algorithm says, pick any random point from P union N, means positive or negative. You don't know to which part the point is actually belonging or the feature is actually belonging to. Now what it says, if the point actually belongs to a positive point, but the weighted sum is less than 0, try to correlate it with the previous equation which we have just discussed. Point is positive, but its weighted sum is less than 0. What the result of this activation will be? 0. But the point should be on the positive side. That means the weight assigned to that input is not correct. You need to update the weight. So what the perceptron learning algorithm says, the weight should be the current weight of that input plus the input feature itself. That will be the new weight. Or if that point belongs to the negative side, but its weighted sum is greater than equal 0, That means point is actually, it should lie on the other side of the line. But its weighted sum is more than that. That means it is again in the wrong side. That means weight assigned to that point is wrong. It is not correct. So again we need to change the weight. So it says weight should be less than that. So with this, and this is repeated till all the points which actually lie on the positive side, they should give you the weighted sum as greater than equal 0, and all the negative points should give you the weighted sum as less than 0. Then all the points are correctly classified. And this algorithm will run till all the points are classified. That means the algorithm is actually converged. So this is what the algorithm says. This is little bit mathematics, and we shall look into this mathematics. This is an example. So we have a two-dimensional plane. We have weight, the equation of a line classifier, and that is W transpose P into X is equal to 0. This is, we all can understand this. So all the points which lie on this line, they will satisfy this equation. WTX is equal to 0. WTX is equal to 0. That means cos alpha at this point will be 90. That means W is perpendicular to this X. Right? Now look at, we have points P1, P2 and P3, positive points. We have points N1, N2 and N3, negative points. And W. If you look at the angle between W and P1, P2, P3, it is less than 90. Yes? Cos less than 90. When this equation is multiplied with, it will give you value greater than equal 0. Angle is less than 90. And all the points which are lying on the other part, the angle between W and those points is greater than 90. Right? So greater than 90 means output will be negative. Negative output will give you 0 output. That means on the other side of the line. So this is the solved example. But in real life, if these points are, this initial weight is not actually in this direction, in that case, because of this algorithm, you will keep on changing the weight. That means for positive points, the angle by changing the weight will keep on decreasing, and the angle between the negative point will keep on increasing. So this is how the perceptron learning algorithm actually works. This is the basic example. I hope all of you are with me. Yes? Okay. So in order to prove that, means to understand what we have discussed on the previous slide. If you look at, when the point was positive, the weighted sum was less than 0, we were increasing the weight. Now look at, on the right hand side of the slide, point is positive, their dot product is less than 0. That means the angle between X and the current weight is greater than 90. Yes or no? Now what we are doing, we are increasing the weight. The new weight will be equal to the current weight plus the input itself. Now if you look at, cos alpha nu is directly proportional to the W nu transpose X, because it's a dot product. Then W nu is W plus X, because W nu is changed, W plus X. So that means cos alpha nu is greater than equal to the previous cos alpha. When this value cos alpha nu will be, when the actual angle between the point and W is less. So this is actually an analytical proof to what we have discussed on the previous slide. On this previous slide. So the actual value of actual cos alpha will be greater if the angle is less. If angle is large, cos alpha value will be less. So this is what the algorithm says for positive point, and it is same for the negative point. Yes. So this is the analytical proof to understand what is happening in the perceptual learning algorithm. Yes, make sense? Okay. Now this was again a question on the previous slide. Okay, fine. So what about the non-Boolean values? So real valued inputs are now allowed in perceptron. This was the earlier question in case of macroscopic neuron, because real life says we cannot have binary inputs only. Then do always need to hand code the threshold. In case of macroscopic neuron, you yourself have to give the thresholding value. But in case of perceptron, that thresholding value can be learned. That thresholding value can be learned. That we call as a bias. Then what it says? Are all inputs equal? No. All the inputs are not equal, and as a result, we are giving them the weight. And weight is nothing but it is give the importance to the inputs. And next is, what about the functions which are not linearly separable? So that means when you have a single perceptron, you cannot solve non-linear problem. So if data is linearly separable, then a single perceptron is sufficient. But if data is non-linear, so simplest example of non-linear data is XOR. XOR. So in case of XOR, it is non-linear. So this you have seen the Boolean gates and or not. We were able to solve them using a single perceptron. But this XOR cannot be solved using a single perceptron. So in most of the scenarios, normally this is a question: what is the XOR problem and why it cannot be solved using a single perceptron? So this is the reason, because a single perceptron can only solve linearly separable data. But here the data is not linearly separable. You can see two blue dots and two red dots. You cannot separate them using a line. Yes? So now one more issue with the perceptron, because perceptron is using a step activation function, thresholding logic. Yes? Either the output will be 0 or its output will be 1. And there is a sharp transformation. If your weighted sum is greater than equal 0, output is 1. If the weighted sum is less than 0, output is 0. Yes or no? So look at this example. Again, it is a real life example. So this is a simple neuron. We have bias weight W0 that you call is the threshold minus 0.5. The weighted importance of the input x1 is W1 is equal to 1. Now look at, if this critics rating value is 0.5, this 0.5 multiplied by 1, 0.5, your output neuron will give you 1. Suppose it is 0.51, this will again output give you 1. That means you like the movie. But if this critics rating is 0.49, what will be the output of the neuron? 0. Means, is it really a real life scenario? And you can say, okay, if the rating is 0.49, I don't like movie. And if rating is 0.5 or 0.51, I like the movie. So this thresholding logic is very harsh. So that means in real life scenarios, this will not work. We have to look for some other activation functions, other thresholding functions that can really do justice with the real life scenarios. So that activation, this is the step function, the thresholding logic. This is one of the suggested activation function sigmoid, and I hope you all understand this. Yes? So this is a smooth transformation. It is not a sharp 0 and 1. The curve is smooth. and you can see the equation of the sigmoid function. Yes? Now, and all of you are aware of that the sigmoid function gives you values between 0 and 1. Yes? Now, the difference between a perceptron, where we have step as the activation function, or the thresholding as the activation function, or the sigmoid as the activation function. So this is what you can see here, the activation function. It will either give you 0 or 1 as an output, but here you will get an output between 0 to 1. So that the harsh decision that cannot work for real life scenarios can be solved with the help of a sigmoid neuron. Now, how to decide the type of activation function to be used? Again, it will depend on your application. So we can decide which type of activation function is suitable for this type of application. That is, again, if time permits, I will touch upon that point also in the upcoming slides. So this is a sigmoid neuron. So in the previous slide, we have, okay, here let us see. Before we talk about the sigmoid neuron, let us try to understand the concept of error. In the classification problem, what we were telling, either the point is correctly classified or point is not correctly classified. In real life scenario, if you look at the data here, we have again somehow linearly classifiable data, blue points and red points, and we have a linear classifier. Now, of course, it is not 100% classifying them, but in real life scenarios, this type of classification is actually acceptable. Means you cannot reduce error to 0, but you can reduce the error to an acceptable value. This is the actual objective in almost all the machine learning, deep learning problems. You cannot reduce your error to 0. But yes, if it reaches up to a acceptable limit, that means you can stop your algorithm at that point of time. So the error. Now let us start a typical machine learning scenario. Then we will see how the machine learning scenario actually deal with what is the concept of error and how it works. So we start with the data. Initially we have data, and based on that data, means the problem which we have at our hand. That data, based on the data, we decide which type of model can be applied on the data. Model means here the simplest model is means when you will get an output. So we can apply different type of models available. So the simplest model, here we have seen a neuron with a sigmoid neuron, or it can be any. You can simply say it is simply an aggregator, the thresholding model also, or the third one also. Then the parameters which you want to learn from the data. Now, in the previous slides, we have seen in McLaughlin neuron, we have to assign the threshold manually, and we don't have the concept of weight. Yes? In perceptron model, we have weight and threshold both. Threshold is called as a bias in case of perceptron. Now, for a real life scenario, if you look at weight and bias, these are the actual learnable parameters in any machine learning, deep learning setup. Means, if you correlate the perceptron learning algorithm But you were changing after every iteration. We were changing the weight. Yes or no? So, do you are manually changing that weight? No. The algorithm was changing. And when the algorithm, we say algorithm will stop when the weights are learned. What does it mean? When the points which we want to classify, they are classified in their correct class. So that is the learning of the weights. So what you want to learn from the setup, weight, and the threshold also, because you cannot again decide the threshold for real life scenarios. So that it should also be learned by the network, your system. So these are the two parameters which your machine, your algorithm learns from the model. Then the learning algorithm. Of course, this we shall be touching upon. Perceptron learning algorithm we have already seen in case of the simple perceptron. Further, when we go for deeper networks, the another algorithm is which most of the models talk about is gradient descent. So this is the most popular algorithm, and Dr. Anil will talk about more advanced versions of the gradient descent. Then the objective function. In the previous slide, we have seen the error. Yes. So when we should stop our algorithm, what should be our objective? What is the acceptable amount of error? Because error will only tell you that whether you have learned what you want to do, whether your objective function has meet out or not. How you will decide based on the error. If it comes to be at the acceptable range, you can stop your model. So this is a typical machine learning setup which we normally follow. This is again that same. Now the objective function or the error function. Again, there is a requirement to understand which objective function, which error function we should use. So you must be aware of the regression problems and the classification problems. Regression problems is we are predicting some real value. Classification problem is our objective is to divide the data into two or more classes. So based on the type of problem at hand, accordingly this error function is to be decided. So again, I will focus on a slide where if your problem is regression problem, then this error function can be a simple squared error function. Squared error. And if your problem is classification problem, then binary cross entropy is an error function which is commonly used in the machine learning setup. The model, again, depending upon the type of application at hand, the type of model is again, we decide which we shall be using, depending upon the type. Of course, the algorithm. So, this I shall be touching upon some of them. A sigmoid neuron with an input, simple sigmoid function. Now, we shall be discussing an example how a sigmoid neuron actually learns, how we do learning. So look at this. We have X as the input with weight W and the bias, and the output y hat or y cap is a function of the sigmoid. It's a sigmoid function. Now what it says, the example is typically the movie example which we have seen on the previous slide, like whether you will like the movie or not. Yes, based on some input, and you are deciding the output. What shall be the output from a sigmoid neuron? Now, here look at your data is n pairs of x and y. So, what does this x and y means? The input and the output pair. X is the input and y is the output. That means for a given input, you know the output. So it's a supervised learning type of setup. Supervised learning type of setup means you know the type of data and the tentative output class it belongs to. The training objective is we want that the machine learning setup should learn weight and bias. These are the two learnable parameters. So here there is a one concept. One is learnable parameters, other one is hyperparameters or non-learnable parameters. So learnable parameters are those parameters which your model learns during experimentation. Non-learnable parameters or the hyperparameters are those parameters which you can give to the model, like the learning rate, like the activation function, which you give to the model. Yes. So moving next. So we have trained the model, and for these 2 points, when input is 0.5, the output is 0.2, and for input 0.2, 0.5, the output is 0.9. And we have fitted a sigmoid function on the graph. Yes. Now, what we want for this input and the particular output, we want that our model should learn the weight and bias that can satisfy this input and output combination. We have input and output combination. We want our model to learn the weight and bias that will give us means for 0.5 the output should be 0.2, and for input 2.5 output should be 0.9. Output of a sigmoid function. We have calculated and we want that we should fit a sigmoid function that should pass on between these 2 points. Now, what we normally do is, initially, of course, the weights and bias is randomly initiated. You have to initiate, you have to give random weights and random bias initially to start with. So suppose at initial point when you are starting your algorithm, your model, initial weight is 0.5 and initial bias is 0. Yes, you have to give initial weight and bias, and that is randomly selected. Now, for that value, you have obtained this graph, this sigmoid output. Now look at, it is not passing through both the points. Means error is large. How you decide the error is large? Because we have already decided that it should pass through these 2 points. That means we need to rerun the algorithm. Yes or no? And what does it mean? Rerun means it will adjust the weight and bias. It will learn, it will change the weight and bias. So for that, this is the error for the first case. And how the error is calculated? This is squared error. If you can look at, you have yi is the actual output and fx of I is the output which is produced by the model for the given set of input. And the square difference, because we have 2 points here, so we have taken these 2 points and the mean of that, you are getting error as 0.073, right? But it is far from the expected output. We will again, the algorithm will redone. It is not converged yet. Another weight and bias. So error has increased. Yes, error has increased. Now another weight and bias value, error is reduced. We are coming closer. And from the last weight and bias values we have seen, error is now very less. And we are very close to our objective. Yes, this is the time we can solve. So this we can test by writing a simple piece of. So we are not doing it manually actually. It appears that we are assigning weight and bias manually. No, algorithm is doing it. We have written a code, and that algorithm is actually doing it. This is actually being used in most of the experimental work. Now coming to what I was talking about. In the previous case, we have discussed about perceptron learning algorithm. Now the gradient. Very important. So look at, of course, here the number of iterations are 1000, but it is not required for this simple setup. So what it says, for iteration t is equal to 0 to maximum iterations, what it is doing, the new weight, because we are learning weight and bias. So new weight is equal to the existing weight minus eta into gradient of the weight. Now what does it mean? We need to understand this gradient word here. So gradient here means, because there is a difference between the actual output and the real output. Means the actual what we have received and the actual target. When we calculate gradient, gradient tells us the direction of change. And here we are taking negative of it. Negative of it. That means how much should be change in the weight that will increase or decrease the loss value. So what we want to increase our loss or we want to decrease our loss? We want to decrease our loss. That's why this is negative. Gradient tells us that direction of change. So what we want? The reverse one. So, and eta here is the learning rate. So learning rate along with the gradient is used for changing the weight. Changing the weight. So eta is normally called as a step size. Step size. So in machine learning or deep learning setup, again this is again a hyperparameter, which you decide what should be the value of this step size. Higher, if the value is very high, you may cross the minima. If value is very less, it will take long time to reach at the minima. So some optimal value again that you will decide based on different hit and trial. Rest, weight and bias, they are changed by the algorithm based on the gradient. Again the gradient you are not calculating, your machine will be calculating that. But we must understand empirically how this gradient is calculated for simple setup and for a complex setup. So for simple setup, we will see how this gradient back propagate in order to change the weight, and rest the machine will do. Of course, the computers will do that. So what is our objective? Finally, we want to learn the weight and bias, and this is the error. Yes, we are calculating the gradient. this one, and this is nothing but it is the partial derivative. We will calculate the partial derivative because we have two variables. Yes, weight and bias. So when we do that, look. So here gradient with respect to W, the weight is fx minus y. So multiplied by this is nothing but it is the differentiation of your sigmoid function multiplied by the input. So this is the change in the weight, which would be multiplied with the learning rate in order to update the weight. Same can be done for the bias, except for bias, this x will not be there. And this is, you can see the differentiation of your sigmoid function. Yes, we have multiplied the value of input over there. So sometimes the setup is very simple. For a single neuron, we have seen when we teach in the class, we normally do it manually so that we have a confidence. If we can solve this for a single neuron setup, then it can be iteratively solved for any complex architecture. That is what, and it will give us a confidence. Yes, this is how it actually appears. Very simple, but because it involves a lot of mathematics, but we all are the student from the mathematics background, so we can easily do this. So the gradient with respect to weight and the gradient with respect to bias, and you can see the things are almost same. In case of weight, the value is multiplied by the input. Here for bias, the input has no role in changing the bias. Yes, so just you can differentiate between the gradient for means changing the weight and changing the bias. Now based on this is a simple code, so you can see or you can easily get it from ChatGPT. But doing like understanding the code and observing each step, that is must. Machine can code it for you, but understanding each step, stop at after every step and see what is the change. That as a student, research scholar, we must devote some time. Now, sir, how much time I can? Okay, okay. Let us see the complex architecture. Then we will stop. So till now we have seen a single neuron. It's a typical multi-layer feed-forward neural network. Now, manually calculating gradient, updating the weight, next to impossible. But if we know the concept, we can understand how the weights are updated and how they are going back. Because ultimately, error is at the output layer. HL is equal to y hat is equal to f of x. And you are changing the weight at the input layer. Here, weight matrix W1. And there are n number of hidden layers. So, very complex structure. Yes or no? But if we understand, yes, it is possible with the chain rule, then we can easily understand the concept. But yes, this is a typical machine learning, artificial neural network, deep learning structure, and it is changed from output to input. We'll be discussing one small formula and you can understand. Rest is, you can see we have L layers, the input layer, the hidden layers and the output layer and their dimensions. And there are n dimensions. And each weight, if you look at this weight, change in this weight is not only depend on this path. This change in the weight will depend on multiple such paths. That means you have to look at the gradients from different paths changing over here. We have just seen change due to one perceptron. So the terminology I am skipping this, no issue. The learning algorithm. So we have seen this for a single perceptron. Yes, weight and bias, only two parameters. Now here, how many parameters? W1, W2 up to Wn, beta 1, beta 2 up to beta L. And W1, W2, Wl, they are all n cross n matrix, n cross k matrix. You can see the size. Yes, but because we have the algorithm, it will do it. So the matrix size will be very large. But there is no need to bother because we have the algorithm. Thanks to the people who have designed these algorithms. We have to simply use them and understand the concept. So how to decide the output function and loss function? So let me go to this. Okay, let me skip this. Yes, I will conclude here. So if we want real valued outputs, then the activation function as the output layer, it can be linear and the loss function can be a squared error. If the output you want in the terms of probabilities, then the activation function at the output layer can be softmax if the number of outputs are more. If the number of output is binary, then you can think of some other activation function also. And similarly, if the loss function output is linear, loss function can be squared error, and if the output is probability, the loss function can be a cross entropy. Binary cross entropy we normally say. And again, there is lot of concept behind how this binary cross entropy. I have skipped so many slides in between before I reach to this slide. Rest of the talk, again, the backpropagation, the real, we can say, but yes, because of we have to continue with the other lecture also. We'll do it sometime later. Thank you all. If anyone have any queries, please. So I have kept this lecture very simple. That is the bias, na? So that's what in case of perceptron I had told you. It is the weights can be negative also. That is the how learning takes place. We are not taking actually. We are randomly initializing. So manually initialization होता नहीं है. What we normally do, we initialize और जो initialization होती है वो between 0 to 1. हम उसको normalize करते हैं and it is normally assigned between 0 to 1. Even inputs को भी हम normalize करते हैं because कुछ real life scenarios में कुछ inputs की value तो बहुत छोटी है, कुछ इनपुट्स की वैल्यू थाउजेंड्स में है, तो वो सभी नॉर्मलाइज की जाती हैं बिफोर द डेटा इज एक्चुअली गिवन टू द मॉडल। एनी अदर? So if there are no further queries, then thank you. Thank you for giving me this opportunity.
Your discussion on perspectro sigmoid neuron machine learning setup gradient descent was truly enlightening and informative. Thank you, sir. Now, I would like to invite us to participate Dr. Ali Kumar Rao, the Sanskrit show and Shrivas as a doctor of our appreciation and warm welcome. Please welcome Dr. Ali Kumar Rao. लेके आती हूँ। है ना HDMI चाहिए ना आपको? मतलब क्या चाहिए आपके आप इसमें वो चला दो सर, आप जो जो मीटिंग चला के शेयर कर देना उसको, बाकी डिस्प्ले आपका कैमरा वगैरह ऐसे चलता रहा है। हाँ व्यू तो ठीक है, लिंक हो गया। हाँ हमने कॉपी तो नहीं किया था ना वो, और उसके लैपटॉप में डाल दिया। फिर लगा कैसे था, वो लगा ही नहीं हुआ, लग गया था। मैं थोड़ा कुछ नहीं, ये यहाँ पे मिल कर रखा है। PCS PCS ये ना, ये वाला ओपन करूँगे वरना। ये ज्वाइन कर क्या है, ज्वाइन ना, ये बताओ। मुझे तो तुम्हें ये चाहिए तो इसमें लगा लेते आप। हम्म, चलो भाई की बात है। क्या था मेल पे, मैं अब ये कह रहे हैं कैसे पता नहीं क्या है। ठीक हो गया, मैं मेल पे डाल देता हूँ ना। ठीक है, ऑफ कर दो, ऑफ करना और म्यूट कर दूंगा इसको। ठीक है, जस्ट वी आर सुनाओ। अब मुझे क्या करना है? अच्छा, तो यहाँ पे चला दो। ये वाला, ये स्क्रीन आ रहा है कि ठीक है, ऐसे, ऐसे done, ठीक है, ओके, बंद कर देता हूँ, ठीक है ना, दिख रहा है ना? हम्म, हाँ चलो, हेलो, एम आई ऑडिबल? वन मोर टाइम। So hello everyone. Now I think you already know what is my name. Today, what is the topic that I would be touching? So sir has covered the deep learning side, where he talked about the neural network, perceptron, the macros, and the pit equation. My objective here is to take you to the next level, and I would also be talking about the previous what has happened. So I'm coming from the industry background, and today what I will do, I will just try to fill the gap that is there. So whatever we are learning or whatever we have learned so far, and yes, most of the time you always have this question like, how do we apply this knowledge, whatever is here, right, to our industry or maybe to our day-to-day life? So today I will just try to fill that gap. And yes, not now the next term is coming up like generative AI. So how many of you have ever heard about this term? What is this generative AI in past? Especially for the student and the researcher, those are here. Any one of you, have you ever heard about what is generative AI? Yes, no? Who else? Okay. Yeah. So today's agenda is like, as I have already mentioned, that I would be talking about. I mean, it's a more into the problem solving. How do we solve the day-to-day life problem? So there's a fuzzy logic that is there. There's a cyber security in the picture. How AI is coming into the picture, and in the AI also how Gen AI is a sort of storm right now. How we are solving most of the problem using the Gen AI, right? So this is how I just try to bridge this gap by this interaction. Hopefully, you will be aware with lot of basic terminologies those are there in the market. For myself, I've already explained like, over 2 decades of experience into the industry. So I have experienced this all the whenever you hear about data science, machine learning, AI, deep learning, generative AI. Nowadays, I believe that all of you have even maybe used ChatGPT. Yes or no, right? But we must be having somewhere in our mind that how it is actually working. Right? So let me just give you the context. Sir gave you a 90, so he started from the 1942 or 1941, some equations, Maclaurin and Pitt. So there is a research paper in 1945 in that this is clearly written that this equation, so sir explained the perceptron and the neuron, right? This equation in the future will speak, will talk, will think, will solve your problem. That line is very powerful. Because when I was doing my PhD, I also, I mean, just read that line and I realized really it is happening. We are into the era where, so we must have heard about, I mean, different kind of wave. The first wave, second wave, third wave kind of, in the humanity as well. Right now, we are into a wave, we call it as a Gen AI wave, generative AI. Whatever examples I has given so far. So sir has talked about, okay, there's a binary classification, sir has talked about there is a regression kind of problem solving, right? Now, I can remember it's a hardly 4 to 5 years ago that I'm talking about. this 2019 or 2020, we got one paper. Attention is all about you. Attention is here. That is the paper that changed the entire spectrum. So I'll try to relate because today, what I want to do here, I want to just whatever the story, whatever the revolution that is actually happening in the market, how can I connect you to that revolution? So that you will also realize that how industry is moving, what is happening in the industries, and how we are solving different kind of problem, those we were not solving earlier. So that is where I'll try my best. When I started my career about 19, 20 years ago, I started from the very beginning, like as an analyst kind of person, where I used to solve a lot of reporting kind of work. I'll let you know what is that reporting. And then, very basic kinds of problem we used to solve. Now, second question that I also want to touch upon here, when I used to, learn a lot of this mathematical equation and everything, lot of geography, algebra and everything, right? I always had this doubt in my mind. Where are we using this? Profit loss is okay, that there is a shop that people are using it in a day-to-day life, right? But how exactly we are using these kind of equations and algorithms in a day-to-day life? I'll try to, take you there. How exactly we are solving those kind of problems right now, and how this revolution is happening under the umbrella of generative AI, right? Before coming to this fuzzy logic is if and what kind of conditions those we are talking about. When we started, right? So sir also has a one like with the one input, two input. I think ma'am also had some problem that can be with the negative weight or something or the positive weight kind of, where we were optimizing our parameter. Some features were there, right? Then we were trying to put some sort of weight. We defined some sort of logic or maybe some loss or cost function. We had gradient descent as an optimization function that was helping us to understand those weights. Everything is happening with the computer, right? With the equation, those are there. So somewhere, what is that we are doing? First, we are identifying what could be possible parameters. When we say parameters, means features. Even before defining any kind of parameter or feature, we are trying to identifying what is the problem that we are having. Problem can be anything. Because at the end, what we are doing, we are trying to solve the problem. What kind of problem? Classification problem we talked about, in the previous session, right? The regression kind of problem that we talked about. Classification problem, let's suppose, I want to classify the thing. At the end objective is what? Classification. So we could have a problem, whether you like this lecture or not. There's a problem. Should we attend any university or not? That's the problem. Whether India will grow tomorrow or not, that's the problem. And what are these problems like? These all are classification problems, those we used to solve. Then we have an entire sort of theory of the math that is in place. We have a code in the place. We come up with the equation and then we try to solve it. When we talk about the regression kind of problem, so where my end objective is the real number, maybe what would be my total score? Everyone want to know that. What would be the number of people those would be maybe enrolled into this university next year? There's a problem that we want to solve. Why do we want to do that? Why? Because accordingly we will take all the different kind of major the decisions, right? So these are the different kind of problems that we used to solve. We have talked about regression. We have talked about the classification. Then how are we solving this problem? Initially what was happening, as sir also mentioned, manually we can do that. If we have a one or two or three kind of parameter, or maybe the feature I'm talking about, feature you can call it like, okay, number of, reason. Let's suppose how many students will enroll into this university. What could be the possible reason to it? What could be the possible, parameter to it? There can be anything, right? Yes or no? Maybe how far this university to that particular person? How many what is the average age or maybe merit or maybe nearest geography? What kind of courses those we are having into this universities? So there could be n number of parameters. So think in a very basic manner. We have n number of parameters. We are trying to solve some problem. These parameters, nothing is a feature. And then what we need to do? We need to assign some sort of weight to these things. Like distance can have a highest weight. Agreed or not agreed? Similarly, it can be negative also. If some course is not relevant at all, then maybe person is not interested. So that has a negative impact. Then it's a negative weight. How do we get that? With the help of some optimization algorithm. Gradient descent is one of algorithm that we talked about in previously session. Correct? So all these things we were doing with the help of, initially we used to call that as a statistical way, the classical step, where we used to call it regression analysis. This problem market, machine learning came into the picture. So someone has already written in 1945 or 1940 that this particular equation will speak, talk, take the context, will interact with the people. In the chat GPT, what we are doing, we are interacting with the computer. Correct? Now I'm just trying to connect the dots so that we are there. So machine learning was there in the market. Same kind of problem we started solving. Then deep learning or neural network came into the market that we call as the artificial intelligence. Why? Because we are talking about the neuron there. Neuron and perceptron is the same. When you go into the biology classes, you will see how human take the decision. We have a neuron, right? We have millions of neurons into our body. So perceptron neuron, this term is exactly coming from there, human body. So the way human think, now researcher or scientists want equation to think in the same way. That is why they invented the neuron. So whatever problem you are trying to solve with the help of stat in the machine learning algorithm, now we tried to solve the similar kind of problem with the help of neuron or the perceptron, and then we started calling that as a artificial intelligence. Why? Because the base theory is same. The way human think, now we want equation to think in the same manner. Internally, what we are doing? Internally, we are identifying the kind of features those are there. Then we are assigning some weight based upon some optimization. But how? Based upon this neural network. Based upon that perceptron. That's explained in the last. That is why we call that as the artificial intelligence. Now, how generative AI is coming into the picture? How Gen AI is coming to the picture? We have reached to the AI. Are we all reached or not? Are we now clear? Now we know little bit of the AI. So whenever we say we are using deep learning, why deep? Because in the human body also we have millions of neurons, not one neuron is working. Billions of neurons are there. Based upon that, we take the decision. How do we see the people? My eye is giving that input to the brain. Brain is just deciding, okay, this is the girl, this is the lady, this is the merit university, and everything. So somewhere we have just learned ourselves. So the way human is learning, similarly we are trying to, make that equation should also learn in the same way. That is why. So multiple sort of neurons those we have in our body. Same we are saying in the neural network, we have a deep neural network where sir just explained the deep neural network at the last. We have having so millions of layers. As a computation, initially we can go with 2, 3, 4, 5, 6 kind of maybe layers. As a human, we have a million. So somewhere we are far behind when we compare to the human, but we are still maybe trying to do that. When we talk about Gen AI, so here you will hear in the beginning the LLM, the large language model, the term. I'll come to this slide because I just want to set the context so that we all know what exactly is happening, what is there. So in the large language model, when we say that a deep neural network is there, number of layers 2, 3, 4, 5 kind of. Number of features is also maybe likewise if I ask you this question that will you enroll in any particular universities, what kind of features that you will take and how many numbers of features that you will consider. Or let's take a real world example. Maybe India will grow maybe by some GDP next year. What could be the number of parameters? What could be number of reason to it? How many? Give me some random answer. How many? Tell me, guys. Everyone, are you telling? Yeah. How many could be the future? India want to grow next year. Random numbers are 50, 60, 70, 100, 1000, 2000, 1 million reasons. 1 million reasons means 10 lakhs of reasons. If I say 1 million means what? I have been through the entire universe. Yes or no? If I say I have 1 million of parameter, it means I have been through the entire universe. So that exactly is happening. When we say large language model, what does that mean? So we are into a race where we see every sort of week or day, we have a large language model coming into the market. And what kind of number of parameters? It has a billion of parameters. What does that mean? That means that a computer or that model has seen all kind of possibilities. So when you ask any question to the chat GPT go back and choose some model there. What is that? So chat GPT is an OpenAI product, right? And OpenAI is having their own sort of model. Now it's a 5.1, 5.0, 4.0. There is the OpenAI itself also. These are the LLM, right? ChatGPT, I mean, OpenAI is one. Google is also having lot many models there. Gemini 2.0. I'll also over the list. We have Anthropic. We have our internal also. I can also come up with my model if I have a system and everything. So these models, everyone is claiming, okay, I got 5 million parameters. Someone says, I got billions of parameters. Someone says, okay, I developed a model and I have a trillions of parameters. So now just think, I mean, what is happening right now? We are into the world where every week we are hearing about the new model. And just think that there is one machine that has looked into your entire Wikipedia, entire universe of text, entire all the knowledge that is there. Now you ask the question, it is answering you. Can you beat that? I didn't know. That is, and we call that as a large language model. Why language? Because it is slowly based on the text we are talking. Similarly, we have a large vision model where we talked about all the images. How do I know this color is black or not? Because somewhere in my childhood, we got to know that color black looks like this. So these are vision models. We got trained by our mind. Same thing we are doing in the machine. So coming back to the topic, so this is what the large language model. Today I will be talking about what is generative AI, how it is important, what kind of problem those we have solved in past. Now what is happening in the industry, what kind of new challenges those we are facing, and what could be the new possibilities. Right? How ChatGPT we all know, we have talked about what is the 5.1 or whatever the model those are there. They all are large language model. And I'll just talk about in this journey. The base was, sir has already mentioned, sir talked about what is the perceptron, what is that neuron, right? How do human think and how do machine think? And how do we solve the problem based upon maybe we took some number of parameters. But now we are into the era where we are trying our best to consider all the possible reasons to solve the particular problem. Okay. So today I just want to connect whatever the traditional way of solving the problem. How do you solve the same problem using the generative AI? I will also get into the term generative. Why it is generative now? What was that earlier that we used to have? fuzzy logic. So when we were trying to solve right now, it's I always feel like okay, it's a sort of I mean, whenever we solve the problem, we have a cutting edge algorithm in the play. It's quite I keep it as a old, but there is I mean, it's all about the problem solving. Sometimes simplicity can solve the problem, then we use that. Why to make it very complex, right? So fuzzy logic, it's all about we try to I mean in the human I mean real world scenario, it is not always zero or one. It's a tentative. We are always confused as a human also in problem solving also. So that's where we, in the fuzzy logic, we come up with what are the fuzzy sets, what are the function, what are the fuzzy if and then kind of rules. So initially, whatever system we used to develop, when maybe we were not talking about AI, machine learning, deep learning, analytics, we always try to come up with some sort of logic. If a person is reading for or 2 hours or 1 hour, then there is high chances that that person will pass. I came up with a very simple logic, right? If maybe demand is so, then result would be that. So those kind of logic we used to develop under the fuzzy logic. Then it has its own sort of theory. I'm not going into the theory because my objective is to get people to the next level, what is happening in the current level. Again, the way we used to optimize here also, we have some sort of logic in place. How do we optimize that? Then we used to solve the industry problem with the help. So when we started in the beginning, we just got to know, okay, this equation will talk, speak, and everything. But when in future, that time let's take a pen and paper, do some logic, do some if and but kind of condition, and solve the problem. That is what we started. Okay? So we were solving the same problem, the supply chain cost optimization, any kind of thing in the industry. One thing is very interesting. We were having problem earlier. We were solving them. We got the new tool, new way to look into those problems. We solved them earlier also with some sort of success. We solve them again with new kind of set of maybe environment that we got. Then we will solve in future also. Every time, what is the objective? Let's minimize the error. Let's take the best accuracy. Let's reach to the best, right? To the highest of this level. So problem is there. Problem is not getting changed. Yeah, now a lot of new problem added. Earlier also we always try to solve, okay, if some person is taking some loan from the bank, what is the probability that that person will pay the loan? Now you take the mathematical equation, that could be a one way. You want to go with the probabilistic theory, that is another way. If you want to go with the machine learning kind of approach, that could be another way. If you want to go with the AI kind of approach where we are talking about the perceptron of the neuron, that can be the another way. Now let's talk about the GenAI with the LLM. Can we solve that? Okay, let's try with that. So what is happening? The way we look into the problem, the way we solve the problem, that is getting added day by day. And good part is we are achieving very good accuracy. In my research, I was part of emotion reduction from the text. When I started in 2019, I started with the classical state. Then I was getting around just think the accuracy of in the problem. I was getting around 58 or 59 when I was classifying the emotions from the text. Then while I was doing the research, I applied the machine learning also because I'm coming my in last 20 decades. I'm pure data science or the AI background person. So I applied the machine learning from 58 to I reached to the 66 or 65. 2019, new algorithm, the LLM came into the market. I also applied them. I also do some sort of optimization too because we need to look into the optimization. We need to look into the loss function. Somewhere we need to define it. I decided, okay, let's define some hybrid function there. That is what the data that I had in my PhD. I came up with that function. I looked into the new algorithm. So whatever accuracy I used to get, the 58% to 65% to 73%, it reached up to 79%. Same problem, algorithm got changed, and I reached from 58 to 79. So that kind of data that we can see while we are looking into the same kind of problem. Okay, so We used to solve these problems, financial risk optimization. You can think of n different kind of problems, but we try to solve them. Yeah. Application like physiology. So physiology is nothing. We are just trying to make some sort of if and but kind of rule based upon certain decisions, and then we are solving them as per the industry. We can apply anywhere, right? Now let's talk about the cybersecurity. That's the biggest threat that right now in the market. Lot of cyber attacks, those are there. Lot of fraud things that is happening. So there also AI playing a very crucial role. When I say AI, now, I mean, 4 or 5 years ago, if you met me, I would always say, okay, AI is the biggest thing that we are doing. 6 or 8 years ago, if you met me, I would be saying that time machine learning is the biggest thing because I do remember when random forest one of the algorithms. Random forest is one of the algorithm, like the regression, loss regression. RF is one of algorithm, and this is very nice. Why? Because sir said like, okay, the data should be linearly separable, correct, in one of place. Machine learning got the popularity. Machine learning started saying, okay, data could be anything. Can be linear, can be non-linear. Let's apply this algorithm. This is very good. So that time we got very fascinated by, okay, this is the algorithm that is gonna solve the problem. Then AI came into the market. It said, okay, in the machine learning, how many features that you were taking? I said I took 15 features. Someone said, okay, I took 100. I do remember in one of companies that I was solving the problem. That is into the retail. What is the probability that person will buy a sort of potato? I was just trying to do that. So that company can come up in the retail shop, you see the offer, right? There. So there's a reasoning behind that. It's not that easy. I mean, they just simply say, okay, 1 kilo aloo is free with a 1 kilo potato. It is not like that. It's a big reasoning that goes in behind. There's a data science, so AI comes into the picture there, right? So there we try to solve that problem. Okay, let's take some sort of decision there. Let's look into what could be the possible feature or the reason whether the person will buy this particular category or this particular product. You may end up with saying, okay, you must have taken a little 10, 20, 30, 100, 200, 300, 500. I started with a 15,000. Because I got the liberty to apply the machine learning algorithm there. In the logical regression, it was quite tough for me. In the machine learning, I applied there. I mean, you can apply there as well. But what I'm saying, the number of features, the scale that we were expanding, we were trying to look at the problem for whole angle, not with the one angle. Right? When we say with the whole angle, then AI came into the picture, and then deep learning algorithm, the perceptron, neuron, ANN, RNN, CNN, all these algorithms in the market, they said, okay, let's not talk about forget about number of features, let's dump all the features, all the possibilities, whatever you can think of, put everything there. Do not worry about it. We'll manage all these things. But computation should be there. And why we are doing it right now? Why not 50 years ago? Because that time computation was the biggest problem. Now you usually have a maybe 32 GB RAM, 32 GB. That time it's a 1 GB or maybe very less, right? So that is the reason that now we can apply these algorithms. So we talked about AI, started solving problem using the AI. Because we can feed n number of feature in a more robust way, can apply, let's not talk about linearity or non-linearity, just put it as a kitchen sink and then let the algorithm decide what would be the best weight for which feature. Let algorithm decide. So that's where machine learning got, these AI got very, popularity because we are somewhere trying to mimic the human thinking as well. Lot of simulation is nothing is optimization that I'm trying to say. We are for whenever we decide define any kind of algorithm, there is optimization, there is a cost function, there is a parameter, there is a feature, there is a weight. Those are the, I think, common terminology that we have already gone through. Real world problem. I have already explained. Problem. You take any kind of problem. We have a solution. When I say solution means we have an approach to tackle that problem. 100% even We are not sure because that is where we are trying to achieve, or that is where we are trying to, get that point, because we are not a god. So whenever you see accuracy like 99% in any kind of research paper algorithm, I always get, okay, something is maybe that's not coming, because it's not possible. We will always see a unseen error, some unexpected things that will always keep coming. So that is why we cannot reach to the 100%. But yes, very good accuracy that we are achieving. Um, in a way, lot of scenarios. I'll skipping very quickly. Uh, so how do we solve the problem? What are the core skills that we usually go? The deep learning algorithm. There is a initially we were having like stats, then predictive modeling, forecasting. All these terms that those are there when we try to solve the problem. Not go in the one by one. Deep learning that we touched about, machine learning I talked about, stats I talked about. Then let's talk about one term, that is discriminative AI versus generative AI. So in the chat GPT, when we ask any question, what do we get? We get answers, right? It generates those answers. It is unique. It is not copying and pasting. It is generating the answer. Now this is the answer to the 50 or 40 years back paper. This equation will speak, will talk, will see. Right? It is generating. You are just putting the question. It is not classifying. We talked about the neural network. Either it's a pass fail, right? 0 1. Now it is not a 0 1. Now AI, these algorithms, these LLM are generating the responses. Then there is a lot of science, lot of maybe, of course, it has a lot of maybe inbuilt reasoning or thinking. How do we generate that? How do we? So it is not. It's the next word prediction that is happening internally. So we saw the very deep neural network. We have an output in place. We feed a lot of input there. Then we get the next word there. So it is a different kind of maybe. So all the neural network, the deep learning algorithm I'm talking about, we classify them as a artificial neural network (ANN), convolutional neural network (CNN). We have a recurrent neural network (RNN). Then there is a multiple variant to it. Multiple variant to it, and in that I'll also show some content there. I don't want to make it complex. I want to make it as a story so that you know that. We need to first understand what is happening, how it is happening. Then whatever component we feel this is a bit complex, you can just study that and you can get to know. Go deeper to it. So in the neural network, lot of architecture changes was happening. When we say LLM, large language model, so they follow some certain of particular architecture in it. So maybe OpenAI 5.1 might be following 13 deep neural hidden layer, some n number of maybe 1 million of parameters. Input they have taken like all the text from the book. When we talk about Mistral, they are saying, okay, we have a maybe 24 as a hidden layer. We have this particular cost function. This is the optimization algorithm, and we have considered all the Wikipedia text, all the book, all the whatever is there. We have taken all the things in place, and we have trained our model. Getting the point? So all these large language models, we classify them also maybe small, medium kind of things, and they follow some sort of architecture in them. And based upon that, we call them as a large language model. Why? Because number of parameters so large there. Very basic, very simple. So that's where, and with the help of this architecture, they try to generate the content. So 4 to 5 years ago, whatever problem we used to solve for the industry, they were mostly either it's a classification problem or it's a regression kind of using the deep neural network algorithm. But now, since we got these algorithms, now we are solving lot of problem towards the generative AI side. For example, text generation, ChatGPT. What is there? You have a bunch of maybe, so you can develop your own sort of chatbot where you can feed all your books. So let's suppose maybe this university want to develop their own sort of app, conversation app. They will feed all the data into it, right? Now you can ask any kind of question. Okay, who was the professor who did research on this area? You don't need to go for Intel library in there, correct? It is your particular channel. What you have done, you have fed all the books information to the algorithm. You have trained the model. You have developed this particular solution. Now you are doing the Q&A. And it is generating the answer, not yes, no, or maybe the regression kind. So last 3 to 4 years, the kind of problem those we have added into our plate, they are more into generative intelligence. Currently also I'm solving another problem for one of the big brand where we are generating a lot of good images and the good videos. The AI generated videos, I mean, you must have heard, right? There are algorithm in the background. How do we generate that? Yes, of course, there is a reasoning, there is a logic, there is a lot of things that goes into the background. So these are the problems, these kind of problems were not there earlier. Now we are solving them. Right? So this is why we call that as a generative AI. This is very powerful. Trust me. Very, very, very powerful. Just think, I mean, just think, I mean, the example that I gave you. Idea how much time you need to invest as a researcher. Even just to get to know what is Maxwell's maybe equation, it takes a lot of time. Now it's a simple prompt or simple line that you need to feed into the system. It will just take you to the relevant context to you and it will just pass, okay, this is a link, this is an everything. It has reduced the time like anything. So all the fuzzy logics, all the cybersecurity and everything. I mean, now we have a habit, and I always had this discussion with my sir that where are we heading to? What is going to happen? I mean, I myself also, okay, let's write a line, okay, this is the answer, okay, copy, Control C, Control V, Control A. So that is actually happening. So we are into the era, we call it as a very revolutionary. We are solving different kind of problem. What are the problem we have solved? We are solving them also. See, in future also something will come, we'll also look at. But now, the kind of problem that we are solving very unique. And they are really very powerful. No one can deny the powerness of these ChatGPT. Right? You can't deny that. They are very powerful. Systems like ChatGPT, systems like, okay, just imagine that I have a system that is generating the images as per my need. Why do I need any photographer? Production need, I don't need that, right? If I could do that. You just think, you develop that, you create that. So creativity is there, generative power is there for the machine. It can, as a human, I cannot recall what I did in the 10 years ago. But as a machine, as a system, it is powerful enough. It has it has gone through for entire kind of Wikipedia, entire kind of text that is there. Now it is answering to you. You cannot beat that particular machine. That is happening. Quickly, when we used to solve the problem, initially we used to try to put, it's a prescriptive problem, it's a predictive problem, it's a diagnostic problem, the descriptive problem. Now we'll talk about how do we solve these problems in the industry. I've already talked about different kind of streams, those are there, right? When we call about the descriptive analytics, it's an old slide that I always, it's quite old, right? So in the descriptive analytics where we talk about, we try to describe the data. In the predictive analytics, we try to predict what is happening is going to next. In the prescriptive analytics, okay, so descriptive, we are just describing our data. Diagnostic, based upon description, we are trying to diagnose what could be the reason that people are feeling very sleepy in this class. First, I'll just look into your faces, then I'll try to diagnose. Okay, this rate is good. This research is okay, giving some sort of attention. This, okay, he is maybe feeling very bad. Predictive, I'll try to predict based upon this. I think I'm a bad person. Or maybe the way I give the lecture, maybe I need to fine tune my perception, I need to fine tune my content, because most of the people are feeling very sleepy into this. That's a predictive. I'm trying to look into the future. Same thing we do into the business. Prescriptive, based upon this, business try to take the decision. Is very, I mean, sort of very basic things. Then a lot of machine learning, the data science. I've already talked about these things as a story. Lot of supervised. So these are technical terms. I'll not get into it. I'll just take as a term. Supervised, unsupervised, reinforcement learning, time series analysis. So I have a data that is totally based upon time. I have to look into the future. I will go with the time series kind of algorithm to solve that kind of problem. Right? So recommendation system, this I have, supervisor has already talked about this. Application side, uh, when we say regression, what are those problems? When we say classification, what are those problems? Algorithm is different that we use to solve these problems. Initially based upon regression classification, classical sets, then it's a machine learning, then is the AI, now it's a generative. In the generative AI also, right? I'll skip these amount. So how? So the neural network we looked into, the deep neural architecture that we looked into. So the fine-tuned version, the next version, that changed the entire. So we call that as a generative pre-trained transformer, GPT. These were the algorithm. From there, we started generating the content. Till this time, we were trying to discriminate the answer most of the time. Then we started, and one more. I'll just skip this. I'll talk about. Yeah, I'll talk about this slide. So when we had this deep neural network in the picture, lot of features, lot of activation function, lot of optimization, lot of things. Correct? That time, 2019 or somewhere, we got transformer into the market. With the help of transformer, we developed a new algorithm. When we developed the new algorithm, we got the new version. When we got the new version, one of version, we started calling that as a GPT. So we have so many variant to it, I would say. And based upon that, so this is the particular algorithm where we have an internal architecture, decoder, encoder, where when we talk about the decoder encoder architecture, it's converted to machine translation and those kind of problem solving. When we talk about the decoder architecture, it tries to generate the content. So in the decoder architecture, what we do, we pass this maybe one input, it tries to generate to the end. So this kind of funnel it goes. Encoder is what? You have an n input, it just converts to the one column. Squeeze the plane. So that is also all these are architecture. Detail, I think you'll be having enough time. Just go later. But right now my intention is very simple. To just fill the break. I mean this gap. So these kind of architecture, those were there. Encoder, decoder, based upon that, we have already talked about discriminative AI, where we are solving the classification of the problem. Generative AI, where we are generating the content. Correct? So these are lot many models. Those are there. Let me just large language model. I think I started with this slide. What is the large language model, so that I can set up the context. Type of LLM. I told you in the beginning. Initially, okay, it's not that overnight these things came. Everything has a history. Likewise, perceptron came 1942, Mac and Pick. Now these are getting popular because now we are using them to solve the business problem. So we have n-gram model, we have a hidden micro model, we have embedding based neural model. Embedding is what? I'll just tell you. So word to vector, globe, these are embedding. We have a pre-trained model, we have a large language model. These are the various kind of different models we see. Uh, okay. As I said in the beginning, on a sort of maybe every week and so, or maybe almost every moment, we are getting a sort of new LLM into the market. I took this from one of research paper 2023. You can see the kind of model. I mean, its list is very huge. You can't even imagine. I mean, number of LLM itself is more than I believe 1,000, 2,000 kind. And everyone is there. So mostly initially when these got popularity, OpenAI was there, Meta was there in the market, Google was there in the market, Anthropic was there in the market, Hugging Face was there in the market, a lot of open source model was there in the market. Right? So many providers they were there in the market. We also categorize them into the based upon size, based upon type, based upon origin, availability, all these kind of. Now this is going much deeper. When we talk about large language model, there's a lot of things those are already in place. Likewise, when we started, when we talked about the machine learning normal stats model, there, I mean, if I say I got the solution for your problem, your question would be, tell me, is it really correct or not? How do you know that this is the solution? Obvious question, right? If I say, okay, these many people, your obvious question would be, oh, I don't agree, I disagree with you. Tell me what is right. I mean, how do you know that this is correct? What I'll say, okay, you don't believe me? Then okay, let's do one thing. Let's take a 2 year of data. Let's apply this algorithm. Look into the result. If you satisfy, then I'm correct. Just apply this. So those kind of, we have a predefined way to it. And for any kind of model or algorithm, we call that as the evaluation criteria, evaluation matrices as well. Those were earlier as well. Those are there for the LLM also. I mean, those are different framework. I mean, we need always a person who can certify the solution, right? That person was doing the earlier also. Maybe his mechanism would be different. Earlier, we would be looking, okay, in case of regression, what is the error overall is coming out? Correct? In the classification, let's see, look into the accuracy side. What is the accuracy that we are getting? So similar in the LLM also, we are also have contextual awareness, faithfulness, goodness, because lot of compliance is also coming into the play. So those kind of matrices are also there. So there's evaluation matrices. Those are there when we look into any kind of large language model. Okay. When we started, because as I said, this is a revolution that is happening. When I said it is a LLM, 5 years ago, I used to show the deep learning. 10 years ago, I used to do machine learning. Prior to that, regression, the logistic regression. I do remember when I started my career in all the banking industry, logistic regression was the biggest piece. You have a predefined feature, applying the logistic regression, this is the biggest thing that we are doing. R&D work. Trust me. And that was very unique in nature in India as well. Most of the time, we used to get very maybe data entry kind of task and something. But very few people, they were lucky enough, they were doing into the maybe regression modeling or the loss regression. Then, so I started with the 5 year, 10 year, 15 year. Now, if you LLM, no, LLM is not popular. What is? It's an agentic AI. It's an AI. It's a generative AI. Now we are talking about agentic AI. So let me brief this also for you so that whenever you explore this section. So agentic AI, we are now developing the agent. What is that? Agent is an autonomous function. I don't want to feed anything there. I want to do myself. I want minimal human intervention in my solution. Why? Human always make error. Machine doesn't. So let's make some system. Let's create some agent. So I have an agent who will talk to or that agent will solve one particular type of problem. So there's a different kind of agent, and that is where agentic AI is coming into the market. Here also we are solving the problem. For example, let's suppose I want to develop a Q&A kind of session, right? I want to develop a solution for Q&A, for you, I mean for any business or something. They says, okay, we have a bunch of data. If someone asks our employee, external people or anyone, they come to us, they ask question, maybe based upon my data, this solution should answer to that question. And okay, but there could be possibility data can also be outside. So few questions that is answered from here, few questions that is answered from some external data. Maybe someone can, funny person come and can say, okay, can you generate a image for this? I mean, some kind of time that also be there, the chat GPT that happened. Right? So we have different kind of ask. What we can do, we can come up with an agentic AI kind of solution. It has a bunch of agent in place. Every agent has its own task to perform, and then they are also talking to each other. And this system is purely autonomous. Zero error. Agree? Let's suppose I want to look into some fintech kind of company where we just want to look into the portfolio. So I have an agent who will just look into what are the verdict those government is giving. Why that is important for me? Because based upon, let's suppose I have some portfolio investment in some particular stock or something, maybe some verdict came wrong. What so? I need to know. I just we just looking into that particular task. Then I have the person who is looking into some other task. I have a third agent that is talking to both the two agents. I hope you're getting my point. So now we are into the era where we try to develop a solution using the agentic AI. Internal also, normally what we say, whenever agent is there, it is using the LLM internally to solve the problem. So few agent can use the LLM, few agent can use the machine learning, few agent can be like, okay, if and but condition, we call them as the orchestration agent. One agent can be like, okay, monitor the class. Okay, if person A comes, then you stand up. If person B comes, you stand up, kind of, right? So there's orchestration agent. So that is where agentic AI comes into the picture. As I said, as a solution or as a data scientist, or we always try to develop an agent. They should be autonomous. They have a feedback loop. If something goes wrong, we have thumbs down button. Next time it will make sure that this response is not relevant. It will reinvent the entire algorithm. Correct? So that is how we call it. So again, very in depth. Every topic is needed like a lot of days. But as I mentioned in the beginning, I just want to bridge the, I mean, fill this gap. We are actually solving the problem. So whenever you do the differentiation, whenever you look into the equations, whenever you look into Maclus and the pit kind of equations, trust me, these are very powerful later. Okay. So autonomous reasoning, planning, tool, memory, collaboration, with the technical terms, those are there. Type of agent, again, lot of theory. Someone says the 4 type, 5 type, 6 type, it's very subject. Right? At the lab, what we are doing, we are trying to solve the problem. And problem can be. Okay. So we have a lot of internal framework to follow. So internally, whenever ChatGPT is there, it must be following some sort of framework. So a lot of frameworks are there: LangChain, LangGraph, Crew, Semantic, ADK. We have a Pydantic, we have orchestration, we have open AI. Well, so there's so many frameworks those are in the market. By using these framework, we try to develop these kind of agentic AI solution. In the agentic AI solution, we have a different kind of agents. Every agent is having some particular task to perform. Whenever he is performing any task, he is calling some sort of algorithm to solve the problem. When we talk about the problem, we are defining that problem, whether it's a regression, loss regression, generative, non-generative, discriminative. So those kind of analysis that we do, and that is how we develop any kind of agentic AI solution as a whole. Yeah. So business problem, as I mentioned, everywhere in the retail means, I mean, in the retail, right? Customer segmentation is a problem, price optimization, fraud detection, image recognition, virtual. So many things I think these are self-explanatory. You already know. It's a very common sense, not a very rocket science kind of thing. It's very common sense that we're talking about. Healthcare, a lot of problems those are there that we can solve. So whenever you see the 2D or 3D kind of images there, you have an MRI scans images, those are there. So what is happening there? We just simply upload that image to the chat GPT or maybe some platform. It just generates the entire report. How does that is happening? Somewhere in the back, we have already developed that model using similar kind of lot many images, right? It has its own sort of process or sort of algorithm to use. Everything is getting originated from that very basic perceptron that's covered in the very first basic. That's the ABCD. Now on top of that, we are building so many with so many dimensions. At the last, solving the problem. Yeah. So these are the problem that is solving. Thank you. I can take any other question. Yeah. Any question?
सर
Yeah.
हाँ पॉलिटिकल इंडस्ट्री में एक प्रॉब्लम है सरकार किसी की सुन नहीं रही है और लोग अपोजिशन को नहीं सुन रहे हैं तो हाउ टू फिल अप दिस गैप एआई कैन हेल्प समथिंग
Yeah, definitely. Now, when you look deeper or go deeper into any kind of political part, they are having their analytical AI or data science. There, they are also assessing whenever I roll out any kind of policies, what is the reaction of the people. Manually, it is not possible. We need some system. We can have one agent for that, fetching all the data from your Facebook, from all the social media. We have emotions attached to it, scoring that. Once policy is getting rolled out, at the same time we are saying, okay, reaction is not that great. For any kind of maybe whenever election happening, you always get proactively, okay, exact, I mean, what are the survey and all that, right? They are also using these kind of algorithm in the background. Yes, as I mentioned in the beginning, problem is there. How do we solve that problem with the different kind of approaches that is based upon our capability? Correct? Someone can quickly go and talk to the people, okay, do you like BJP, Congress, or whatever? Right. Now generative AI will tell based upon your context and based upon kind of symptoms that you are giving. Yeah.
Sir,
Yeah, please.
sir, one more thing for natural intelligence, the environment is dynamic one
Yeah,
and evolutionary also.
correct.
For this artificial intelligence, what is the kind of state of environment?
Yeah.
It is static, dynamic, evolutionary, by cell or by human?
Yeah. Okay. So when sir says the environment, somewhere we are talking about kind of features that we are feeding into the problem. Is it dynamic? Is it static? So as I start from the beginning in the step, we have a 2, 3, 4 kind of step. Those days we used to face this kind of problem. Okay, it's a black, it's only take about 4. We have so many problems there. Then we got machine learning. Then we also counter that argument. Okay, now we have entered maybe 15,000. What else do you need? No, but still this is very dynamic. Corona came. How will you tackle this problem? Then I said, okay, I am now using the LLM where I have taken all the history, I have taken all the geography, all the universe. What else do you need? Then you will say, no, this is still missing. Then I say, okay, just wait. Let me talk about quantum computing. There also I am saying that it's very natural in place. Let me use that, apply my AI, solve this problem. So this cycle will keep on. Because at the last, I said, room is always there for the improvement. We have not reached to the, we are not the God. No one is the God. The moment we will say we are 100%, then I think then nothing is left. So this room for improvement will always there. There is the way we try to attempt the problem will always keep happening in
The
future.
artificial environment is also key.
Always, always, always. On. Correct. Correct.
Thank.
Yes. Yep.
The human being generate any
Correct.
content.
Correct.
I can do the errors.
Yeah. Yeah.
So today I can understand how ChatGPT is generating citations, generating references for me.
Yeah.
It is generating 25, 30 research papers which I have never wrote.
Yeah. Correct. Correct. Correct.
So it simply means that it is also doing the errors.
Yeah. Yeah.
How
yeah.
can we rely on it?
Okay. So there's a one thing. These all are algorithm. How they are maybe built that I have covered. So someone says I have used entire Wikipedia data, but someone has already misleaded the information there, right? As a machine, I am taking that, right? At the same time, revolution is also happening. I said there is one person who is watching us. The solution is correct or not? Yes or no? So whatever topic I touch, every topic has a research in it. When I say the evaluation mechanism, it's very deep. It's not so small. Evaluation can be like, oh, what are the citations? Those are coming, these are wrong. So somewhere algorithm need to be corrected. Correct? So right now, most of the, because as a human also, how do we say that whatever this person is saying correct or not? Based upon some human judgment. Then the some quality person can be okay. Let's put some human judgment also as a score. If I'm generating any kind of image, because this I just recently finished, or some video, is it really good or not? How do I recently doing? By looking at it, okay, let's do the same thing. Let's come up with some sort of score. So those things, revolution will always happen. These kind of error will always need a human intervention to review.
Yes.
Right? Yes, this is just a starting. With the time, with the feedback, it will get increased.
And sir, it was very funny when I said, why are you not citing my papers? I have written 25 papers on this subject. He immediately apologized and gave the 25 papers
25.
in my name.
Yeah. Because the way someone has set that algorithm, maybe the prompt comes like this, answer is this, not satisfied, do that, or response like that. So as we mentioned, it's a starting. With that time, things will get fine tuned and we'll have something new to come. I mentioned every week we have a new LLM in place. Every week. And that is where, so this is the reason I mentioned in my beginning, we are living in an era that is very revolutionary. The revolution is exactly happening right now. Thank you. Hmm? Yeah. Okay. Now these are terminology. Ontology क्यों बोलते हैं, biology क्यों बोलते हैं? So natural language processing is a natural language means text processing you're working with that. So whenever we talk about any text-based kind of solution, we always try to put that into NLP area. Whenever we talk about any kind of image kind of problem, we always put that as a computer vision side, right? So it's just a terminology. NLP is nothing. We are dealing with the language model. Then we talk about the multi-model, where we are also dealing with the language. We are also talking about the image. Image can also have a language in it, right? So there's a multi-model. So this is just a talk. Right now, OpenAI, Google Gemini 2.5, 3.0 plus. Agentic AI is a sort of framework where you have a lot many agents in place. Every agent is calling the LLM to solve that particular area. Likewise, in a university, professor has a different job, librarian has a different job, cameraman has a different job, security guard has a different job. Everyone has their different job, but it's a university. There is one a coordinator. Similar kind of solution or similar kind of things. Whenever we are approaching any problem, we are trying to solve in the same. So that's the agentic. So many agents, and that is why we are calling that as a agentic AI. So then we have evaluation matrices for that. Yeah. So then, as I mentioned, I just touched the topic. Topic is in the inside, right? I just touched the topic, and these are very vast. Agentic AI, agent itself has a lot of 6 months kind of course, right? You can research, do the research there also. So agent is autonomous. Agent is should be foolproof. There is a RAI check. There is a guardrails in place. You cannot ask. I mean, now if let's suppose I am to develop any kind of agentic solution, you can ask about how to create a bomb. Then I'll be sued. I'll be down. So I will make sure that no one will ask this question, right? So they come under the guardrails. Yeah. Yes.
Thank you so much, sir, for such engaging and mesmerizing session. Uh, Now, I would like to honor Dr. Anil sir with a token of appreciation as a gesture of our gratitude. I would like to request our respected HOD sir and other dignitaries to come forward and present the memento, certificate, and kit to sir. Please, sir. On behalf of Department of Mathematics, I sincerely thank Dr. Anil Kumar Jadhav sir, Senior Manager Data Science at Publicis SIBN Gurugram, for delivering such an insightful and inspiring session on integrating fuzzy logic and generative AI. Sir, we are truly grateful for your valuable time and meaningful contribution to our 5-day international workshop on artificial intelligence. Thank you so much, sir. Okay. Now I would like to request our honorable dignitaries to come for lunch. Fine. Uh, at and to sorry. Yes, ma'am. Well, first of all, आप सभी and this invitation is for all of us, and we will assemble here at 2:30. Thank you. Yes.
जहाँ पे इसको कर सकते थे सर मुझे 50 में आनी चाहिए सर सर कोई बात आपके कुछ भी अच्छा लगता है
तो आपको इसको भी घूम जाओ आपकी मैक्सिमम को कंसिडर किया है अपने को मेरा मेरा तो मेरा तो है मिलने में इसको मेरा काम है फिर कोई लगी अब ये दोनों का भारी काम तो नहीं है भारी तो किसी बात नहीं है अरे सर आइए नमस्कार बात में ठीक से नमस्कार आप कह रहे हैं अरे सर वीकेंड जल्दी नहीं देखो और कोई लेने कोई बात नहीं है हाँ ऐश्वर्य क्या से बात कर आप क्या है अच्छा
Welcome, Professor Nancy. We will start the session within 1 or 2 minutes.
Sure, sir.
Okay.
Professor Nancy Sharma
Yes,
is
please.
present here.
Yes, good afternoon, everyone.
We are not getting your voice.
Am I audible?
Please unmute yourself.
Yes, I have already unmuted
Please
myself.
unmute yourself.
I have done that.
Your voice is very less.
I have already unmuted myself. Am I audible? Am I audible to everyone?
Yes, ma'am, audible.
Thank you.
नहीं, उनकी तरफ से. You will start, Charlie.
Good afternoon to all. This is our new next session for today's program. In this session, I would like to invite Professor Nancy Sharma. With over 24 years of academic experience, presently Dr. Nancy Sharma is a professor and principal at ITS Mohan Nagar, Ghaziabad, with her areas of interest as database technologies, artificial intelligence, and data science in the field of computer science. She is an IT professional who had delivered specialized invited talks and sessions on latest IT trends and technologies as keynote speaker at many reputed platforms. She had also provided trainings as a resource person to the personnel of prominent government organizations, including training to Indian Air Force staff and training to employees of Ghaziabad District Authority on IT modules. She has been honored by Shikshak Samman on 5th September 2021, conferred jointly by Uttar Pradesh Government Higher Education Department and CCS University Meerut for her contribution in the field of higher education and has received many awards and accolades as women achiever and academicians towards recognizing efforts, commitment and contributions towards education and institutional responsibilities. Today she will be delivering a talk on cyber security challenges and AI-based defense mechanisms. Please join me in welcoming Professor Nancy Sharma.
Thank you so much for the introduction. First of all, I wish to convey my deep regards and thanks to MK Sharma sir for giving me this opportunity.
Ma'am,
Yes, please.
may you use any headphone or mic? He is very slow.
Okay, let me find out. Just give me 1 minute, please.
Hello. Uh, Nancy ma'am, please unmute yourself because we are not getting your voice. No, ma'am, we are not getting your voice clearly. Your voice is very slow. But
Am I audible now?
Hello. Hello.
Sir, am I audible now?
yes, ma'am, you are audible.
Thank you. Hope my voice is clear to everyone now. Shall I start?
Yes, please, you will start.
Good afternoon, ma'am. Yeah, good afternoon, sir. I hope my voice is clear to you.
Yes, ma'am. This is clear.
All right. So first of all, I want to thank Mukesh sir for giving me this opportunity to interact with you all and having this session. Um, Let me start with my sharing of my screen. So the topic for my talk today is generative AI and cybersecurity challenges, and I will be focusing more on deepfake as the AI generated attacks and the need for the AI powered defense mechanism. And myself is Dr. Nancy Sharma, and I am a computer science faculty. So to begin with the talk, in the past few days of this workshop, I have attended the other sessions also, and I have understood that a lot of terms related to cyber security, cyber crime, then cyber attack, cyber threats, and the cyber security were discussed quite a lot. So when we talk about the cybersecurity, what we understand is that the cybersecurity is the practice of protecting digital systems, the networks, and the data from unauthorized access, the attacks and the damage to ensure digital security and safe online operations. Already we had discussed a lot about computer security in the past few days, few sessions as well, and we have also talked about all these terminologies like cybercrime, the hackers, security frauds network, and similarly we talk about a lot of terminologies with respect to the cyber security and the breach of the security as well. We have also discussed about the cyber attacks and viruses we all know. So these are the common terminologies when it comes to the cyber security. So what I am going to do, I will be talking a little bit about the generative AI portion, and I will begin my talk with the topic generative AI and the deepfakes. So as we all know that artificial intelligence is a terminology which is related to a system or machine which is designed to mimic a human intelligence. And these systems actually help us in making decisions and solving the problems. And we very well know that artificial intelligence is becoming day by day very powerful and transformative technology in today's world. So we can see it here that we all know that AI is always available. That means 24/7 artificial intelligence is available, and unlike human beings, artificial intelligence AI system do not need breaks, and they do not need rest or the sleep. So they keep on working, throughout the time, and also AI never gets bored or may get tired. So human beings can experience fatigue, maybe the stress or emotional fluctuations, but artificial intelligence do not get tired. Likewise, if we talk about artificial intelligence in terms of doing the automative tasks or the tasks which are repetitive in nature, so again, the tasks which are boring or maybe the time consuming, which human being may feel so as boring or repetitive, AI can keep on doing all these tasks without any issues or maybe concerns. Likewise, artificial intelligence can analyze a large amount of data in seconds, which a human being may take months, maybe years, or maybe like that to identify patterns. But AI can do all those work in seconds. Of course, nowadays AI is also being used as a subject matter expert in solving different problems in the learning patterns and also in different industries to make decisions. So if we talk about artificial intelligence, it is actually offering efficiency, then the reliability and intelligence also, which may not be limited by the human constraints. So its ability to work non-stop and processing a huge amount of data or the information makes it the most powerful tool of these times. So now coming to this diagram, we all are aware about artificial intelligence, the machine learning, deep learning, Gen AI, LLM. In the previous sessions also, a lot of speakers talk about it, and we can see that here each of the inner circle represents the subset of the outer circle. So if we go into the deeper, we can understand that artificial intelligence is a broad concept. And when we talk about machine learning, it is actually a subset of AI. And in machine learning in ML systems, ML basically the systems learn from data and the experience. And we all know a lot of algorithms are there. And when we go deep down, then we have deep learning as a concept, which is a subset of machine learning. And it also uses neural networks with multiple layers. And we all know about the working of these algorithms, which are actually meant for automatically learn from patterns from large amount of data. And then it comes, the next one is Gen AI, which is generative AI. And it is a specialized area basically within the deep learning, which is focused on creating new content basically. And this content can be text, it can be an image, or it can be audio or the video as well. So basically, Gen AI is not just about predicting or classifying, but it is actually generating output. And we are very well aware about ChatGPT and AI and other models or the systems which comes under Gen AI, generative AI. Then LLM models, we know large language models, which are the subset of generative AI. And these models are trained on massive text data set to understand and generate human life language. So when we talk about generative AI, we can see here that generative AI is now being used by multiple industries, and it is actually changing or transforming the way we work and the business operates. Now here we can see that there are a lot of categories and the application areas where we can see that generative AI is helping. And as I already mentioned that generative AI is helping in generating the text. And of course, ChatGPT is one of those applications where we are writing articles, essay, and a lot of other things. The code generation and a lot of other applications are there with respect to the usage of generative AI for text generation. Likewise, images can be created, the video and animation, audio, music, just like human-like voices. Then in healthcare again, a lot of generative AI applications are there. So I will not be talking in detail about all these applications because my focus will be primarily on the cyber attacks, the cyber threats, and the security challenges with respect to the content which is being generated by using AI and the generative models. So as I mentioned that generative AI applications are in all the sectors, including healthcare, the motion picture industry, and we can see here that a lot of search engine services is also there, and at different places, generative AI are being used. So to begin with and to understand the basics of generative AI means as a definition, we can understand it as that generative AI basically refers to a class of artificial intelligence models which are capable of generating new and the original contents like text, images, music, or even the code. And it is actually based on the pattern which are learned from the existing data. So just like traditional AI, which is primarily focusing on the patterns, on recognizing the patterns and making predictive predictions, generative AI creates something which is entirely new and the creative within the boundaries of its training. So in the yesterday's session also, a lot of real life and real world examples of cyber attacks using generative AI were discussed, where AI was used in phishing attacks and malware development. Also, a lot of applications were there. So if we talk in detail about the cyber security, cyber threats with generative AI, we can see here that deepfake is something which is one of the biggest concern today. And the rise of deepfake and AI-powered cyber attacks are increasing day by day. We can see here that AI-powered phishing attacks where personalized phishing messages, just like mimicking the human written styles, are also one of the threats. So malware creation, then disinformation, propaganda, adversarial AI attack, data poisoning, and automation of social engineering are the biggest cyber threats which are coming across nowadays, increasing day by day with the use of generative AI. So basically, generative AI as an offensive approach looks into the factor that phishing, malware attacks, deepfakes, and most importantly, the identity threats. So all these are the growing threats of deepfake in nowadays. So let us begin with the concept of understanding about deepfake. Now, what is deepfake? So basically, deepfakes are digitally altered, or we can call it as artificially created videos, or maybe the audio clips or the images that use generative AI to make something look real or just appear real, even when it has never happened. Means what we want to say, this is a synthetic media. A media can be in the form of audio clips, it can be in the form of video clips, or it can be in the form of images, and it will be imitating an individual with full pattern in a way that it seems to be real. So these tools nowadays, there are a lot of AI tools which are using advanced technologies to create very, very realistic fake content and carry out complex digital crimes automatically. And by using deep learning technologies, these systems can copy a person's face or the movements or the voice with impressive accuracy. And therefore, it becomes very, very difficult to tell the difference between the real content and the fake content. So I'm going to share a few, I wish to share a few videos just to make you understand and aware about the real world examples and the real world scams which are related to deepfake. And I'm very sure that most of us must have been coming across with all these, in the era of social media engagements. So I'm trying to play this video, and if it is not audible to you, please let me know.
What is a deepfake video? Recently, a fake video of actress Rashmika Mandanna went viral in which she is visibly objectified. She has then spoken out, describing the situation as scary. So, how does this fake video come about? A portmanteau of deep learning and fake, deepfakes are the manipulation of facial appearance through deep generative methods. In similar terms, it refers to artificial videos that have been digitally manipulated using AI to convincingly replace one person's likeness with that of another. This phenomenon gained media prominence in 2021 after deepfake videos of actor Tom Cruise emerged online. During the Delhi Assembly elections, BJP reportedly used deepfakes of its leader Manoj Tiwari for campaigning. Deepfakes have gained considerable infamy for their potential use in creating fake sexual videos, hate speech, and politically manipulative material that undermines democracy. So, how do you see deepfakes being used in the future? What is?
So, as you have seen in this video, that basic understanding, if we talk about the deepfakes, it is something where, deep. See, the term deepfake is originated from the combination of deep learning and fake word. So, deep learning is actually a subset of AI, and the content which is being created, it may be in fraudulent in nature. So when we talk about deep learning is actually a form of machine learning where models are trained to automatically discover and learn features from data. And like any traditional machine learning, which actually required manual feature extraction, the deep learning models actually operate at a deeper level. And it enables to analyze complex patterns and generate highly realistic outputs. So we can see it here that the examples of deepfake, like attackers who are impersonating the company leaders, like CEO of any company, or maybe the public figures. Like recently, we have seen some videos, the videos where Home Minister were, addressing to the nation, and similarly, a lot of other videos and the cases we have seen coming across. Even in small businesses, with the help of emails, only the cyber criminals, they can use AI generated voice recordings just to imitate like CEO of a company, and can instruct the employees to approve the financial transactions which may be fraud in nature. And the BFSI sector, by default, it is the most vulnerable sector to have the deepfake based frauds. One of the most important part is that we all in the BFSI sector, we have online KYC system, know your customer processes. So with the use of all these technologies, the deepfake technologies, the attackers can very easily clone a person's voice or maybe the face, and then can use it just to make sure and tell the person to reflect it as a genuine individual. So basically, deepfake calls use voice cloning technologies to break down the customer's attack accounts and do the fraud transactions. So we have also seen recently, if you recall, in March 2022, we have seen during the Russia-Ukraine war, we have seen that a deepfake video of Ukraine President Zelensky was uh, on social media and news channels, where he was asking his soldiers to lay down their weapons. So immediately authorities quickly responded and said that the videos were deep fake and it was removed. But similarly, lot of other areas are there where this kind of content is available on social medias or maybe at the public platforms, and these may create a lot of problems. So initially, when deepfakes were made, it was basically made for the purpose of entertainment, like for movies or for dubbing or maybe for sound recordings. But later, what it happened, this technology keep on getting advanced, and then deepfake start, increasingly developed and misused. So the lot of deepfake videos and audio clips were used to spread false information and or maybe stealing someone's identity as well, and also to harm the reputation of celebrities or maybe the other people, those who are having big names. One very important threat nowadays is the threat to the social security also, to the national security also. Like the social engineering scams basically nowadays is posing a lot of challenge in front of every one of us, because these are the scams or the tricks which are being used by cyber criminals to fool people basically. Means like they are not attacking the computers basically. In social engineering scams, basically the trust of the people, of the human beings are being attacked. They are being fearful. The people, the human beings are being fearful, and they are
Excuse me,
yes please.
slide is not moving.
I have not moved the slide yet.
Acha, acha. Okay,
Yes,
okay,
I'm trying
okay,
to
okay.
explain it.
Thank you, thank you.
I'm just trying to explain that social engineering is also one of
Oh.
biggest scam nowadays, where the cyber criminals are basically fooling the people and asking them to share their personal information or the money. By creating fear, some kind of fear. If I'm not wrong, you must have heard about a lot of recent cases in India. One case in Kanpur was there when a retired engineer was kept under digital arrest for 19 days, and the criminals were posing themselves as CBI and the Supreme Court officials, and they keep on asking him to be under digital arrest and giving money, and lot of similar kind of scams are nowadays increasing. And as per a report, in 2025 alone, in 2025, over 92,000 more than 92,000 incidents of digital arrest frauds were reported across India, and the victims were ranging from senior citizens to the professionals also. So the point here is that the cases which are related to the deepfake content, like audio, video, are increasing. I'm going to share one more video with you all, where the stock market is a video of a known personality in this sector was used to manipulate the stock market. So I'm going to share that video with you all.
We have a professional analysis team to assist you, as well as investors who have already made money to share their experiences. Do you really understand the stock market? Come join us now. Our beloved leader, who has emerged as the greatest global leader of our times, and he is Sri Narendra Bhai Modi. So we created a completely free stock forum community to introduce the most popular stock.
So we can see here that there are two videos in this video. There are two clips there. One is related to the fake video, and one is the original video which was there in a summit. So what is happening here? The criminals or the cyber attackers are using an original content, which can be in the form of video or in the form of audios also. Then using some technology, some algorithms, some processes, and create a fake content. And then use that content to gain the trust of the common people or the trust of the people or to create fear. And what is the agenda behind it? They want to get succeed with respect to the with respect to doing frauds and frauds in terms of financial frauds also, and likewise to create fear also. So we can see here that as per a report of Forbes 2022 24, sorry, as per that report, the global detection of deepfake based cyber incidents were increased up to 245%, and it is year on year from quarter 1 of 2023 to quarter 1 of 2024. So this is the concern, this is the growing concern around this technology. And also it is to be noted that as per the Business World Report of December 2022, it was mentioned that the deepfake cases in India are increased by 550% since year 2019. And this loss is actually in terms of finances also. So the loss which is projected with these deepfake cases is reaching to 70,000 crores by 2024 all alone. So the point here is that it is important to understand that the advanced artificial intelligence techniques where deepfakes can replicate a person's blinking pattern, maybe the head movements or the facial expressions or the voice pattern or the vocal pattern we can call. So it is very, very alarming. It is very, very dangerous. And in some cases, even the creators can manipulate these medias to make it appear as though the individual is saying things which actually never happened. So it becomes more realistic. So these AI-generated synthetic media are meant to exploit for the financial frauds or to do personal attacks also. So this is actually a very, very growing concern in nowadays, and experts have recently emphasized an urgent need for advanced AI-driven detection tools and different deepfake verification platforms. Yes, of course, the public awareness is very, very important, and government regulations and the strict rules are also very, very important, so that we as a society can actually counter this rising danger with the same speed. Why I am calling it the same speed? Because all these contents and all these, the reports and the data shows that the growth in terms of scams, the deepfake scams is rising very, very fastly. And it includes all kind of things, means the facial expression, your head movements, your voice, your blinking of eyes. It's like whatever it is related to your original video, which is there in your original video, can be used as an input or as a data to create new content which can be, alarming, which can be threat in days to come. So, if we talk about the milestone in this deepfake technology, we can see that basically in early 19th, some early work related to the video rewrite was done, and it actually demonstrated that how automated lip syncing and face manipulation can be done. And it helps to establish the foundation of digital image and video manipulation. Afterwards, in 2014, basically, generative adversarial network, we all know that it was introduced, and it actually laid the foundation for having realistic AI-generated media. And later on, in year 2017, first time the term deepfake emerged when Reddit user posted celebrity face swap video using deep learning. And afterwards, in 2018 till 2020, deepfake gained public attention also, and because the tools were much easier to use, and the tools were readily available, and the content, started getting prepared and spread online. So since 2020 till date, till nowadays, till now, this deepfake technology has become more advanced, and it is already expanded from entertainment to the other areas like misinformation, doing frauds or political manipulations, or even personalized cyber attacks also. So what we have to understand is that what initially it was meant for entertainment, but now it is actually doing what? It is actually evolved in a way that it is going far beyond entertainment, and now it is being used in serious context where it is attacking someone personally. We all know the latest cases of celebrity. In November 2025, only just 1 month back, very popular actor Chiranjeevi, he has filed a case for AI-based deepfake videos. Scrolling on the social media. So lot of cases are there. Lot of use cases are there which can actually make us understand the real challenge and real threat of using generative AI to create fake content. So now let us talk about the types of content. So deepfake basically includes various forms of synthetic media. Like I have already told that audio deepfake are there where we use fake video recordings. That means that makes it like someone said something which never happened. And then deepfake, video deepfakes and the text deepfakes. So I have already mentioned all these points here. So now let us understand that how these are created, so that we should be able to understand that if deepfake are using some advanced AI techniques, then we should be able to know that how it is created, so that we can we should be able to cope up to detect all these contents, so that we can take the preventive or the corrective measure. So the technologies like generative adversarial network, we call it as GANs, to provide. So these are the commonly used deepfake creation, which trains itself to recognize pattern using algorithms. And these networks basically train on large data sets of images, video, and audio recordings of an individual, and allowing the algorithms to produce synthetic media that closely mimics the person's appearance and voice. And what happened as a result, deepfake can be remarkably convincing for any individual, and it is very difficult to distinguish between the authentic content or the recordings or the videos. So now let us understand how actually deepfake works. So deepfake technology basically relies on two major types of machine learning model. Number one is discriminative and another one is generative. And each of these models, both of these models play a different role in creating or detecting synthetic media. So if we talk about generative model, so these are basically used to create realistic fake content, and it is aimed to learn the underlying patterns in real data and use that knowledge to create new realistic look like media. And these are trained on large data sets of real faces, voices, and gestures, and then generate new synthetic content that looks like genuine and the real. So basically, these models are producing fake faces, the synthetic voices, or the altered video or the audio. So generative models are the core technology behind deepfake creation. And nowadays, what is happening? The modern scammers are actually using transformer and the voice cloning and the face diffusion models. Means like they are not only using the traditional GAN models, but they are using a combination of different kind of models which makes it more difficult to detect the fake content. And if we see that there are a lot of algorithms which are available, means if we talk about deepfake technology, basically it uses advanced AI algorithms to manipulate faces, voices, expressions, and the key methods basically involve autoencoder and CNN and other speech synthesis models. So we can see it here that the face swapping is one technique which uses algorithms to map one person's facial expression onto another's face. And in this, of course, we have autoencoders and CNN available. And basically, what is happening, if we can see it here in this image, this is an image which is taken from a research paper. And the source I have already mentioned in this slide. You can go through this paper and to know more about it. So we can see it here that the creation of a deepfake is using an autoencoder and decoder. And the same encoder decoder pair is used to learn the latent features of the faces during training. And while during generation, decoder was are swapped, such that latent face A is subjected to decode B to generate face A with the feature of face B. So what I'm trying to say is that basically all these algorithms, the technique face swapping can be used to map one person's facial expression onto another person's face. Similarly, lip syncing. It involves mapping of a voice recording from one or multiple contexts to a video recording in another to make the subject of the video appear to say something authentic, means something which is never said, but it is meant to make it more realistic. So, lip syncing technology basically involves different kind of, again, the algorithms. RNN, I have already mentioned it here. You can see it that a lot of researches are being done in this field to know that how RNN based video production model can help to put words in the mouth of other public figures in the real time. So different models are available. Of course, voice cloning is one another area which reproduces target person's speech characteristics using audio synthesis algorithms like text-to-speech models or speaker embedding models are there. So all these models are being trained on large data sets, and then these all together are making this possible that how a fake content is being generated. So now coming to the next point, which is a discriminated model. This is actually designed to differentiate between the categories like to decide whether an image or the video or the audio clip is real or manipulated. And basically this focus on patterns in the data to assign correct labels like real, fake, then authentic, or maybe manipulated. And the models which are the examples of the models for discriminating models are logistic regression, decision tree, SVM, neural networks. So all these models are particularly used for deepfake detection because they analyze features like unusual blinking patterns or maybe mismatched lightings or unnatural lip movement and similar kind of pattern. The most important part here is that the GANs, which I have already mentioned, it brings both the models together and that too in a loop. So it has basically two models. One is generator, another one is the discriminator. So generator create fake content, and the discriminator tries to detect whether the content is real or fake. So this is actually a very important thing to understand, that if the gen training process is like a competition and it is being repeated multiple times, means like for example, if some real samples of data set are being fed or given to the system, so generator will create fake data. It will produce synthetic data from random noises and other kind of thing, and the discriminator will try to correct the classify and will correct the real and fake samples, and the feedback from the discriminator will go to generator, and the generator will learn to produce more realistic data based on the discriminator's feedback. So now what will happen over the time, the generator becomes so good that the discriminator will be finding it really difficult to distinguish between the real from the fake. So the goal is basically for such models is to balance the both. Means the discriminator should be trying to maximizing the classification accuracy, but the generator should be trying best to minimize the detection. So this is something which we are actually looking into it, and the generated effects nowadays are becoming so realistic that even the discriminators are struggling to tell the difference. So moving ahead, we can see that there are few techniques which can be used to detect the defects, and basically it requires a combination of advanced technology, forensic analysis, cybersecurity intelligence, and the human observation. So basically, when the defect videos and the content is generated, we have to think like that how we can secure the system, how can we detect the content whether it is fake or real. So a layered defense approach is needed. Means what it means to say? It means to say that there should be some technical tools available which can help to detect. There should be some forensic methods, the cyber forensic methods available, and of course there should be a security policies at the organizational level, as well as there should be some strict rules which can protect individuals and the institution or the organization where these threats are imposing. So, to begin with the detection and the prevention from this defect, the very first thing, very important in the first line of defense is human observation. So, first of all, if we want to understand that whether it is fake or real, we can detect it. We can try to detect it through, through our natural ways, through human observations. So, means like for example, any irregular blinking rate is there. If you can see that there is some fake content is there, and you want to see if it is possible, some unnatural eye movements can be noticed, or it can be seen that some we can call it as like some distorted or unnatural body proportion is there, or some unrealistic hair texture is there, or maybe the skin tone is changed, and or the head or the body part is is mismatching. So these are the little bit of human observation. But since, as I mentioned earlier, that the technology is advancing, it is very difficult and just near to impossible nowadays to observe and detect it from the human observations. So what we need? We need AI-powered defense mechanism in cybersecurity, and these modern cybersecurity framework will leverage artificial intelligence to analyze massive data sets and then detect the anomalies in real time, and then of course block the cyber threats also. So number one, if we talk about, it is AI-based defect detection software. So there are a lot of tools available which uses machine learning algorithms to scan images, videos, audios to find out the anomalies. And basically these tools and algorithms will analyze and detect the inconsistent lighting or the shadows or the irregular frames or the pixel levels distortion, or maybe some unnatural lip syncing kind of thing. So these irregularities are often invisible to the human eye, but algorithms can easily detect it if it is trained properly. So basically, AI-driven cyber defense relies on the advanced detection models and tools that can identify known and the unknown threats with high precision. So the common AI-based detection algorithm or the approaches include machine learning, classification models using SVM, random forest, NAVE, and other anomaly detection algorithms. And then deep learning techniques like CNN, RNN, LSTM, all these can be used in phishing email detection, the voice spoofing analysis, and other behavioral biometrics as well. And then we have adversarial AI models where generative adversarial network can be used to detect deepfakes or the synthetic media and the tampered content as well, the digital content. And then neural network based intrusion detection systems, which we call as IDS, IPS, can be used to detect the network anomaly or the zero-day attack. Other than these, when we talk about cybersecurity in a holistic approach, and when we talk about AI-powered defense mechanism, forensic authentication is also very, very important. So when we talk about metadata analysis, there are digital files which contains metadata like device ID or the logs or the editing logs or the timestamps, which can actually reveal very, very easily that whether the content has been altered or not. So this can be used as one of the method to detect or to understand or differentiate between fake and the real videos or the content. Then forensic frame by frame examination is another way where an investigator actually break videos into individual frames using forensic softwares and try to understand that is there any distortion or any unnatural transitions or any inconsistencies in the motion and likewise. Then audio forensic, it is again another method to analyze the audio content. And in this audio analysis tool basically detect about the irregular pitch or the tone or the unrealistic breathing patterns also. So these techniques actually uncover synthetic speech patterns which are actually designed to impersonate the real videos. Blockchain is another area. Yesterday in the session, a lot of discussions about blockchain technology were used. So blockchain technology actually can add a strong layer of authenticity to digital content by enabling verification of original text, images, videos against the manipulated one. We know that blockchain records are decentralized and timestamps, so genuine media can be securely stored and validated without risk. Watermark content again, digital footprints, fingerprints, or the cryptographic signatures, or similar thing can be embedded and stored on the blockchain. So there are other methods also. There are specialized detection tools also available nowadays, and a lot of different technologies are helping in identifying manipulating contents. Here I have mentioned few tools also which are available there in the market, like Google's in ID, then TruePic, Intel Fake Catcher, then DuckDuckGoose, and all these are the specialized detection tools which are available nowadays and proactively watermarking AI generated content. So it is very, very important to establish and enforce the security policies nowadays, because a strong security posture is very, very important to understand that deepfake and the related technologies are actually not only nowadays creating problem just like any other cybersecurity threat, but it is actually breaking the trust of the human beings, and it is coming down as a personal attack. It is not just cyber attack. It is a personal attack as well. So India needs to be prepared. There should be responsive initiatives. And as per the report of Economics Times dated 20th November 2025, a lot of research projects and different tools and resources are, coming across, and a lot of efforts are being put up by the academic fraternity in this field, and a lot of projects are going forward to have real-time detection of the images, videos, and audios, and a lot of other efforts are being put to detect the deepfake content and to neutralize it. So my effort today is just to make you aware about the growing challenge and to make you understand that this is something which we all have to understand, that the technology is growing at a speed where we all have never thought of, and we have to really put our best effort to understand the need of an hour and put our best efforts to cope up and cope up with the challenges, the growing challenges related to the cyber security. So that's all from my side. Thank you.
Question, please. मैम एक क्वेरी थी कि इंडिया में जो थ्रेट लेवल डिग्री ऑफ थ्रेट लेवल है, क्या यूएस और यूरोपियन कंट्रीज में उसी डिग्री पे थ्रेट लेवल है?
सर उससे ज्यादा है।
हैं?
उससे ज्यादा है क्योंकि एडवांसमेंट वहां पर पहले स्टार्ट हुए हैं और वो यहाँ तक अब एक्सटेंड हो रहे हैं, और काफी ये ग्लोबल चैलेंजेस है। जो मैंने अभी आपको एक रिपोर्ट का बताया था, फॉर्ब्स की जो 2024 की रिपोर्ट है, उसके अकॉर्डिंगली ग्लोबल चैलेंजेस हैं और 245% का ग्लोबल हाइक है, सर्ज है। सो दिस इज अ really very alarming, and it is a very new field, and after 2020 ये बहुत ही रैपिड स्पीड से बढ़ा है। हम सभी लोग जानते हैं डिजिटल अरेस्ट का मैं भी आपको वीडियो नहीं दिखा पाई हूँ, इतना ज्यादा डेंजरस है व्हेन इट कम्स टू द सोशल इंजीनियरिंग, क्योंकि एक मासेस को टारगेट कर रहा है। सोशल मीडिया नाउअडेज हमारे लिए नीड है, तो ये कहीं ना कहीं एक बहुत सीरियस एक थ्रेट है, और ये सिर्फ साइबर सिक्योरिटी तक नहीं है, ये एक कहीं ना कहीं पर्सनल अटैक तक जा रहा है। So this is what it is.
तो वेस्ट में भी उसी डिग्री पे थ्रेट है जितना कि हमारा ईस्ट में
ग्लोबल चैलेंजेस।
क्योंकि आई थॉट कि वी आर मोर वर्किंग विद इमोशंस, व्हाइल डिग्री ऑफ इमोशनल वर्क इन वेस्ट इज लेस, तो शायद वहां कम हो, लेकिन ग्लोबल चैलेंज है। थैंक यू सो मच मैम, थैंक यू।
Any query? No. On behalf of the organizing committee, I am deeply honored to extend a heartfelt vote of thanks to Professor Nancy Sharma for her exceptional talk on cybersecurity challenges and AI-based mechanism. Her insightful exposition on how generative AI is transforming the cyber threat landscape from deepfake-driven social engineering, highly targeted phishing, and AI-assisted intrusion has been both eye-opening and thought-provoking. The ASC highlight AI-powered defensive strategies such as anomaly detection, AI-assisted threat intelligence, and deepfake detection system offer us a clear picture of how AI can act not only as a threat multiplier but also a powerful shield in modern digital security. We sincerely thank you, ma'am, for sharing your expertise, time, and valuable perspectives with us, and for inspiring us to think more critically about secure and responsible AI-driven systems. Once again, thank you so much, ma'am.
Thank you so much.
Thank you so much for giving me this opportunity. Thank you.
There is a 15-minute tea break. You are all invited for tea. और जी
उसके बाद ऐसा नहीं कि वहीं से चाय के लोग चले अभी लास्ट सेशन बाकी है सर आप यही बता रहे हैं कि AI के साथ सॉल्यूशन के साथ जो प्रॉब्लम्स क्रिएट हो रही है उसकी बात करो
श्योर सर
क्योंकि ऑडियंस इज आल्सो आवर प्रॉब्लम बहुत सारा
प्लीज रीच समवन at 3:45 p.m.
सारा क्या करें
श्योर
On behalf of the organizing committee, I request the dignitaries to kindly come forward to felicitate our esteemed speaker, Dr. Dharmendra Tripathi, with a sapling, shriffle, and shawl as a mark of respect and gratitude. Please, sir, come. Thank you, sir. Now, it's my honor to introduce our guest, esteemed speaker, Dr. Dharmendra Tripathi. Dr. Dharmendra Tripathi has been working as an associate professor in the Department of Mathematics, National Institute of Technology, Uttarakhand. Prior to joining NIT Uttarakhand, he has worked in various reputed institutions like Manipal University, Jaipur, NIT Delhi, IIT Ropar, and BITS Pilani, Hyderabad. He has completed his PhD in 2009 from Indian Institute of Technology, BHU, and MSc in Mathematics from Banaras Hindu University. His research work is focused on mathematical modeling and simulation of biological flows in deformable domains, peristaltic flow of Newtonian and non-Newtonian fluids, membrane-based pumping flow models, dynamics of various infectious disease, microfluidics, CFD, biomechanics, heat transfer, nanofluids, energy system, numerical methods, etc. He has supervised 9 PhD students and 5 are working under his supervision. He has also guided various UG and PG projects. He has published more than 200 papers in reputed international journals, 3 edited books in Springer, 2 edited books in CRC, 12 book chapters, and presented more than 40 papers in international and national conferences. He has been listed in top 2% researchers, scientists across the world as per updated science-wide author database of standard citation indicators since 2020. Now, please welcome, sir.
Hello. So very good afternoon and good evening to all. And I'm very thankful to Professor Mukesh Sharma and the entire team of this workshop who has given this opportunity to interact you all in this offline mode. And my research is totally different from the theme of your workshop, but I am trying to relate my research with the theme of the workshop, because everywhere people are now talking about the data science, AI, ML, and neural network. So we have to, as a
As a mathematics, we have to learn whatever the technologies or whatever the new domain of the research are coming. We have to learn and we have to think that how we can relate our research with the new technology, because we have to run with the society. If we will not run with the society, then we will be very, back, and the people will be very far. So we have to run with the with the society, with the research, with the technology. Then we can talk something and we can compete to the society. So this is the very basic, work where I will start with the overview of the fluid dynamics, overview of the biofluid dynamics, and then we will come to the how we can relate or how we can use AI technique to solve the system of partial differential equation, and we can see the how much simulation is accurate as compared to the numerical solution. So all those things I have taken. I will try to cover most of the things. Let us see. So fluid, you all are aware about the. So you can see the outline of my talk is overview of the fluid mechanics, overview of the biofluid, overview of the AL, ML, and then role of the AI, ML in the fluid mechanics and the mathematical model and the result discussion. So I think the audience is a mixed type, so we will start with very basic. If you don't know ABCD of the fluid, then I think you can understand and you can have at least some interest to start your work in the field of fluid mechanics. Because most of the people from the engineering background, from the science, from the mathematics, they are working on the fluid mechanics, but their aim is different. So you can see that fluid mechanics, two words are there. So first we should know about the mechanics, and from the school level we are learning what is the mechanics and how we define the mechanics. And when you define the mechanics in the form of study of any object or study of any particle object, any type of material is available in the nature, and you have to study that material. Either there are two position, either it is in the rest position or it is in the moving position. So there are no another option. So whatever the options are there, based on that you can define the mechanics. So when the things are, or when the object will be, I think it will not work. So when the things will be rest, that means rest means it is equilibrium position. So equilibrium position means whatever the forces applied to this object, the sum of the force should be zero. Then it is equilibrium position. So when I think it will not work in this pointer काम नहीं करता है इसमें कोई बात नहीं ठीक है समझ में आ जाएगा मैं बोल दूंगा ठीक है तो when you study any object in the rest position you can define as the statics and when the things are moving means there is a difference. When the difference is there, that means it can be the difference of the forces, it can be the difference of pressure, it can be the difference of voltage, it can be the difference of temperature, it can be the difference of anything. Because any movement, any flow, you can only find when there is a difference or when there is a deformation. So when there is a deformation, like heat flow, high temperature to low temperature, fluid flow, high pressure to low pressure, current flow, high voltage to low voltage. So like that you can see the flow and there is a deformation. So when the force, some of the forces or some of the pressures, if it is not equal to zero, means there is a positive or negative. So when negative difference is there, means high to low, then there is a negative gradient. Because gradient, how we are calculating? So if two parameters are there, two quantities are there, or two variables are there, when you take the difference with respect to the distance, then you can find out the gradient. So when such type of things are there, you can define the statics and dynamics. And when we come to the fluid, that is the mechanics word, how you define the mechanics, then fluid. So fluid is nothing but it is a any type of material, but it has certain properties. How you can categorize the fluid or solid. So when there is a deformation, due to the certain level of force or certain level of stress, force per unit area is the stress. So either you define in the form of stress or you define in the form of force. So if there is a force and if there is a deformation, suppose this is the material, and when we apply the force, and if you can see there is a deformation in this material, then this material is a fluid. And the fluid is again categorized in two forms. And one is a liquid and another is a gaseous. So in the fluid form, it is known as the incompressible and the compressible. Compressible means gaseous state and incompressible means it is a liquid state. And another state, solid. So in three stated, there are some physical properties or geological properties. Like when the fluid is having the more viscous. If the viscosity is more, then it is a liquid. If the elasticity is more, then it is a solid. And if the density will change with respect to the time or when you apply some forces, and the density of the material will change if it is not constant. Because density is constant in the case of liquid, in the case of solid, but when density will change, okay, when the concentration will change, then you can define that type of material or that type of state is a gaseous state. So all this state you can define, but in the fluid we can only consider the two states. One is the gaseous and another is the liquid. And the gas is a compressible fluid because you can compress. That's why it is known as a compressible. When you are not able to compress, then it is incompressible. So how we define the different type of material based on different type of properties. So that is important. You cannot find such type of things in the book. I have also used the AI tools to find the many data. How we can define the different type of material. Because the theme of this workshop is AI. So I have used AI to prepare the PPT. Okay? And then, but one of the workshop I was attending, and the professor, recently I was attending in MNIT Allahabad, sir. I was a speaker there also. So the director of MNIT Allahabad and director of MNIT Mizoram, he is the good mathematician, Professor Sundar. You can find him some interview in NIT, IIT. Most of the places he is going as an expert. So Professor Sundar, so they are discussing about the AI. AI means artificial intelligence. So MNIT Allahabad director was questioning why it is artificial intelligence. What type of artificial involved in this intelligence? The question of the answer of that director was given by another director, and his answer was, since there is no natural algorithm or there is no mathematical algorithm behind this intelligence, that's why it is known as artificial intelligence. This is good for the knowledge, good for the society, but to use the artificial intelligence, our natural intelligence should be very smart. So if we are very smart, means we have the intelligence, we are also intelligent. You are listening that I am intelligent, you are intelligent, everyone is intelligent. Intelligent means what? We have knowledge. So when we have knowledge, how we can use our knowledge and this technology to make more knowledgeable. So our main focus as a professor or faculty, as a teacher, student, our role is how we can use the technology and make it more useful, more applicable and more eco-friendly for the society. So that is the main objective. So when you know the subject, you can ask the question, because making the question is not easy. Okay. Again, I just tell you one of the discussion with my director. He is the additional director in NIT Bhopal, and he is having the additional role in my for my NIT. So I was discussing with him regarding the promotion. So what he told me that I used to ask our faculty member to bring the question paper, and based on the question paper, I am more comfortable to know that how our faculty member are teaching and whether I should promote or not, without listening the answer, because a single person cannot know every subject. As a director, I have to sit in all the interview, whether it is mathematics, physics, history, but I cannot understand everything, and the experts are asking whether the candidate is a. So making the questions is very important, and it is not easy if you don't know the subject. So when you know the subject, same thing is applicable in the research. If you are good in the basic, because now students what they are doing, and as a supervisor what we are doing, we are giving some paper, and the students are solving the paper, and they are finding some gap, small gap, and they are just fulfilling that gap, and come with the new paper and publishing that paper and this. But they don't know what is the concept or what is the basic theory behind that problem. So first that's why everywhere now the coursework is introduced in the PhD program. Earlier it was not there, but now. So when the subject, if you have command, then your work, same problem, same work. If you have good knowledge of that subject, that will be published good and very reputed in international journal as compared to the paper which you will publish without knowing the subject. You just see. What I am telling is not easy, because the writing of the work is not easy. When you know the complete subject, then you can write that work. Your small contribution will be very high level. Your small contribution, but your concept will be very clear. And the viewer and the editor who are in your field, working in your field, they can easily identify that how much you know from the writing skill of the paper. So that is very important. So you should learn. No need to publish 10 papers, 20 papers in your PhD, but you learn how we can work on that particular problem, what are the subjects involved for that problem, and what are the basic concepts behind that subject. Then I think you will be able to learn many things. So you see that I have taken the very interesting categorization of the fluid, like based on the compressibility. Based on the compressibility, you can categorize the fluid in the form of incompressible, compressible, and one more categorization you can find out, find here, quasi-incompressible liquid. Honestly, I am speaking, I don't know about this before the preparation of this PPT. Because earlier, I used to talk or teach students only two types, compressible and incompressible. When I search the category of the fluid from AI, then I come to know that there is another category, and then I search what is the quasi-incompressible fluid. And then I found that if, see, what is the definition of the compressibility and incompressible? Means liquid and gases, when you apply some force and there is a change in the density. So when there is a change in the density, it is not very fast or very exponentially or linearly or quadratic, mathematically we can say, maybe it is linearly change, quadratic, cubic, or exponentially. Okay, but when the change is very slow, you cannot even observe. So when the change is very slow, then it is in between the compressible fluid and the incompressible. So that type of fluid you can categorize in the form of quasi incompressible or quasi compressible. Both you can. So this is the new where you can see that how you can then based on the viscosity. Based on the viscosity, so in the fluid, generally we used to take the Newton's law of the viscosity. Newton's law of viscosity states that the stress is directly proportional to rate of deformation. For the solid or for the elasticity, we use the Hooke's law, where the stress is directly proportional to deformation. Stress is directly proportional to information. In the proportionality constant involved in that rule, that is known as the elastic Young's modulus or elastic constant. And in this case, when the stress is directly proportional to rate of deformation, that is also velocity gradient, then the proportionality constant introduced, that is known as the viscosity. So viscosity, based on the viscosity, we can define the material property or geological property, and many people are working on the material science. So you can define the fluid again based on the viscous behavior, and if the Newton's law will follow. So Newton's law will follow means if we see the mathematically what is the law, means when you apply the stress, there is the deformation. And when this deformation is again with respect to the time, so we can find out the rate of deformation. And when we see the relation between both, because we can interpolate in the form of mathematical relation. So when we have the data, like when we apply the force, there is a deformation with respect to time, and we can observe or we can make in the form of table, like this is amount of stress we applied, and this deformation we found, and then we plot the graph. And when the graph is linear, when the graph is linear and passing through the origin, so this is the when the y is equal to mx. Y is equal to mx form relation will come, that is the Newton's law of viscosity mathematically. So you have to understand physics mathematically, geometrically, and physically. If all three, state or all three, we can say that the modes, if you have in the mind how we can define the problem mathematically, physically, and geometrically. That's why the similarity transform comes in the picture. We are looking the kinematic similarity, kinetic similarity, dynamic similarity, and geometric similarity. So this is the material, but you can see that how it is similar, whether it is geometrically similar when we see the dimension, geometrically similar when we see the velocity. Okay, then it is the dynamic velocity and acceleration. When we are looking the forces, if the forces are similar, then it is the kinetic similarity. So all type of similarity you can see mathematically and physically as well. So same thing when we see the Newton's law of viscosity, it is nothing but it is just a straight line equation, but it is passing through the origin. So what are the failure of the Newton's law? Mathematically, we can see it should not pass through the origin, or it should not be the linear. So when the non-linearity will also come from the origin, then again there are some rule or there is another relation. And when the line is not passing through the origin, again there is a rule. So when line is not passing through the origin, what is the physics behind that? That means when we are applying some forces, there is no deformation. That is the meaning. When we are applying some force, there is no meaning. Means line is going some places. So what is that place? That is the threshold value. or yielding point, turning point, means up to this level, when we apply the force, there is no effect or there is no deformation, but after that, the deformation starts. So why this is happening? Due to the plasticity. If the plasticity is there in the material, then there is no deformation. And after that, the deformation will start. So when the deformation will start, again it is linear, again it is non-linear. Okay, so there are many possibilities. So based on that, you see as a mathematics, how many possibilities or how many cases we can make through the mathematics. We can make straight line y is equal to mx. We can make y is equal to mx plus c. We can make y is equal to mx square. We can make y is equal to mx square plus c. Like that, we can make different type of relation, different type of mathematical relations, and then we can define the non-Newtonian fluid. So non-Newtonian fluid and whatever the liquids you are finding in the nature, except the water, because water we are considering as a Newtonian. Except water, whether it is oil, toothpaste, blood, or whatever liquids are available in the nature, most of the liquids are non-Newtonian. And you can define with different type of mathematical relation. So you can see some example, and based on the idealization, because as a mathematics people, we are also thinking in the imaginary form. Okay, not in n dimension. We can think or we can imagine, which is not possible. So based on the imagination, based on the idealization, like it can be the fluid where there is no viscosity, there is no density, there is no elasticity, there is no surface tension, there is no any physical property of the liquid, but it can be. Okay, you cannot find. So that type of fluid is known as the ideal fluid, and that is also known as the imaginary fluid. Okay, and if you cannot see such type of fluid, because all the fluids we can only see in the nature, and that type of fluid is known as the real fluid. Okay, and or perfect fluid. So perfect fluid or real fluid, you can find where it has some property, it has some viscosity, it has some surface tension, elasticity, everything you can find. So that type of fluid is known as the, so based on idealization, you can find and then based on the homogeneity. So homogeneous nature, when you are taking the different type of liquids and mixing the liquids, whether it is homogeneous or not. So if the composition of 2 or 3, your solute and the solvent, if it is a uniform, then you can find out it is homogeneous nature. Otherwise, you can find the fluid is a heterogeneous nature. Then based on the miscibility, you can see when you mix water and milk, you can find out both will be mixable, but water and oil, it is not mixable. So based on that property, you can define the fluid as a miscible fluid or immiscible fluid. Then based on the phase, so there are different phases or different layers in the fluid, like blood. If you see the blood, there are various RBC, WBC, plasma, and platelets are there in the plasma. So you can see that different layers are there, and based on their viscosity, their layers are there. So when you change the viscosity, their layer may be vary. Okay, so sometimes if the high viscosity fluid is there, then it is in bottom. Slightly, lighter, it is, so you can see the different layer. So based on that, you can find out the single phase fluid, multi-phase fluid, and based on the temperature. Another property like temperature or thermal property, if you can find out everywhere the temperature is same. ISO means what? Same. So it is isothermal. If it is not, then it is a non-isothermal. Then time dependent again, based on the time, if the fluid nature or fluid flow or flow analysis, if we are studying with respect to time, because total dimension in the nature is a 3. Everyone is, but one more variable we are introducing as a time, so it is like 4. And we know that three-dimensional problem we can consider with time or without time. So when time is involved, then that type of problem is known as a transient problem, or unsteady or non-steady. And if it is time independent, then that type of problem is known as a steady problem. So based on that, again, see another category, quasi-steady. That means the change in the physical properties are very slow with respect to time. Means if you can remove the time parameter, there is no change in the analysis. There is no much change. But if you are considering the time and there is very small or negligible type of changes are there, you can find out the quasi-steady. And this type of quasi-steady, now people are using the fractional calculus. Okay? And the fractional calculus, if you see the application of the fractional calculus in the fluid, the change in the state, like from gaseous to liquid, liquid to solid, you can see the derivation, like alpha from 0 to 1. You can define the relation of the stress and the deformation with the fractional derivative. You can find out the transformation from gaseous to liquid, liquid to solid. I will come to some model also. You can see the viscoelastic material where the fluid, how liquid can convert to the solid and the solid can convert to the liquid due to the mathematical transformation from 0 to 1 derivative. Okay. So the application of the fractional calculus, because it is again very much questionable. Fractional calculus. Many people are working on the fractional calculus, but it is again questionable that what is the geometrical property or geometrical value or geometrical meaning, okay, of fractional derivative or fractional integration. Okay, and again, what is the application? So application you can talk if you have the material, but still geometrically it is not. If you can do, then it will be the one of the very novel, innovative research in the field of mathematics. Because many people are doing on the fractional calculus, but they are not able, like dy by dt. We know that is the rate of change. But what will be the d alpha y upon dt alpha? No one can ask tell about this the meaning of, right, sir? Yes. So this is very much you can see, but quasi steady flow you can see the application. Then again the uniform and the non-uniform. It is again based on the velocity. In the flow design, in the channel, in the drug, if the flow is there, and you can see that there is a change at step by step or position by position, velocity is changing. Okay, then it is non-uniform. But if the velocity is uniform, constant, there is no change, means del V upon del T, means acceleration is 0. Okay, then uniformity you can find out. So mathematically you can define, physically you can define, and then you can see that another type of category of the flow, like laminar, transition, and turbulent nature. So based on the streamline or path, fluid particle when it is moving, so it is traveling through some path. So when there is a path, if based on the path, means if the path is very parallel, if the path are very parallel, you cannot see the intersection between their path. Every fluid particle is having their certain path, and there is no intersection. Then it is in laminar form. But again, there is a non-dimensional number that is known as the Reynolds number, and it is the ratio of inertia and the viscous force. And based on the value of the Reynolds number, you can also define the nature of the flow. If the Reynolds number value is less than 2000, it is laminar. If it is in 2000 to 4000, it is transition. If it is more than 4000, it is a turbulent nature. But if you have the streamline pattern, no information about the Reynolds number, only you have the streamline pattern, or when you are focusing, concentrating on the any fluid flow, suppose river, in the river water is flowing, and your concentration in the some layer of the flow, you can find out whether it is laminar or whether it is transition or whether it is turbulent based on their pattern. So based on the pattern, you can also identify the nature. Then compressible and incompressible already I have discussed, like when the fluid is compressible, then the flow is compressible flow. When the fluid is incompressible, then the flow is incompressible. So nothing is different in the flow and the fluid. So when rotational and the irrotational flow, you can see that sometimes the fluid flow is only in the horizontal or vertical direction, but sometimes the flow is circulating at some point. In the river, you can also find if the some places, if the depth is more, okay, the water is circulating. That means the role of angular momentum will come. So when the angular momentum will come, or angular velocity will come in the this flow analysis, that type of flow is a rotational flow and irrotational. Again, you can see the application of the vector calculus, gradient, divergence, and the curl. So curl of the vector field, if the mathematically vector field is defined, and when you find out the curl del cross q, if it is 0, then it is a irrotational. And if it is not 0, then see, every physics is having the mathematics. So when you relate all those mathematics, you can mathematically define and you can find out this. So when one dimensional, two dimensional, three dimensional, and the viscous and the inviscid flow, again if the viscosity is there, then that type of flow is the viscous flow. If viscosity is not there, then you can find out the inviscid flow. Then internal and external flow, like one of the example I have given, water is flowing through the river. Okay, there is no boundary. If there is a boundary, complete boundary or closed shape of the flow regime, then that type of like blood flow, urine flow, or esophageal movement, or intestinal movement. So such type of flow, or if the oil is being transported one place to another place through the pipe, so the pipe is also close boundary. So that type of flow you can find out in interior and external force or internal flow. Then compressible. Again, there is a very important number that is known as the Mach number, and based on the value of the Mach number or ranges of the Mach number, you can define the flow in different form like subsonic, transonic, supersonic, and hypersonic. So those who are working in the compressible fluid dynamics, because my field is the incompressible, but those who are working like aerodynamics or aircraft design, all such type of analysis they are doing through the compressible flow analysis, how to calculate the drag, how to calculate the shape of the aircraft. So all those things are very important because they are flowing or flying in the air, and air is a fluid. So how much air is affecting to the aircraft, all those analysis they are calculating. After that they are going for the manufacturing. It is not easy to develop. That's why you can see the shape of the aircraft is different from the vehicle which we are running on the road. So there are the different. Then you can find out the open channel and the closed channel or conduct flow. Like again same, if the channel is open, then you can if the channel is like glass, okay, and the fluid is flowing, it is open, one side open, okay, and if it is closed, then again you can find out. So different type of category you can see, and think about then again the force you can find out. Some cases it is the force driven flow, and in some cases it is the natural driven flow. Like I will tell you one of the example, the natural flows like water in the river is coming from the hills and going to the plain and sea. Okay, so that type of flow is the natural flow. There is no external force. But the same thing, water you are taking from the river and supplying to your houses a different tank by using some pump. Okay, so from the pump we are creating the external forces. So that type of flow you can consider as the force. Means there is a pressure, there is a force. So force driven or pressure driven flow, or you can find out the natural. Like when we are eating anything or drinking, okay, the flow is not due to the some force. हम कुछ ऐसा नहीं करते हैं कि उसको डाल के ऐसे ऐसे करते हैं, फोर्स लगाते हैं. There is no such. So this is the natural phenomena. So such type of flow you can find out the natural. Then again, based on the thermal property, you can define the isothermal, adiabatic, and the non-isothermal flow. So when the temperature remains constant, means it is same. Then isothermal, no heat transfer between the fluid and the surrounding. It is the adiabatic, and a non-isothermal flow when temperature varies due to the heat transfer or energy exchange. So this type of flow you can find out. Then again, hydrostatic and the hydrodynamic. I started with the static and dynamic, and hydro means water. So when you do the analysis of the water, like water is filled in this glass, this is the example of hydrostatic. This is the example of hydrostatic. If I just throw the water, okay, or if I use some tab in this glass, and when we see the flow of this water, that is the example of hydrodynamics. So hydrodynamics, hydrostatics, you can find out then the single phase, multi-phase again based on the fluid properties. If it is the phase, multi-phase fluid, like in the layers, like liquid or liquid gas or solid liquid, then such type of phases you can consider as a different type. So we have various model you can see, but the basic concept behind that you can see. Then again, see the non-Newtonian fluid, like time dependent. Okay, non-Newtonian. I have already explained what is the non-Newtonian fluid, so no need to read everything. I just make some. Okay. Then again, the non-Newtonian fluid we can define based on the time dependent and time independent. So time independent non-Newtonian fluid is having more models, and most of the people they are working on the time independent non-Newtonian fluids. But for time dependent we have only two models. But you can think about more models if you are able. So first model you can see like I have already explained that if the stress is directly proportional to gamma dot. Gamma dot means the gamma is the deformation. Gamma dot means the rate of deformation. And when we make it non-linear, this n. So when again see there are three possibilities for n. N is equal to 1, then it will be the Newtonian model. If n is less than, then it is shear thinning behavior, and if n is greater than 1, then shear thickening behavior. So like that you can discuss. And again, the shear thinning is known as a pseudoplastic, and the shear thickening is known as a dilatant. So such type of fluid, categorization you can find out and see that another type of non-Newtonian fluid, where I have already mentioned that if there is a plasticity in the material, then you can find out the viscoplastic. So see that this is the yielding stress. Like after this state, there is a deformation, and the other cases are all passing through the origin. But this linear is the Newtonian, rest are the non-Newtonian model. So from the geometry, from the mathematical and the definition, you can find out all this. So these models are the viscoplastic model. Like as a mathematics people, we can play with this m and the n. So these two powers we can play and see that how many models are available. So if it is experimentally valid, you can use. If it is not, because these all models are standard models, so it is experimentally valid. But as a mathematics people, you can take many values, like not y only one and one half. You can take 1/4. You can take 3, 4. But you should work experimentally also, like how we can find out such type of relation for the particular material where we can interpolate the function and find out such type of relation. Because interpolation, when the data is available, we can use the data and then interpolate the data and find out the function. So same thing is there. So you can do it and just see another type of viscoelastic fluid. Viscoelastic material is also same. Viscoelastic fluid you can also define in same way. Okay. So what we can use in the circuit, different type of resistance, capacitance we are using in the different way. We can use in the series form, we can use in the parallel form. So in this case also the same flexibility is there. Like one is the elastic property and another is the viscous property. This is known as a spot. This is known as a spring. So spring is representing the elastic property and the spot is representing the viscous property. And when we take, and this is defined through the Newton's law of viscosity, this is defined with the Hooke's law. So when we consider two different type of property in the series or in the parallel, second case you can see this is the parallel combination, this is the series combination. We can find one of the viscoelastic model in the form of Maxwell and it is in the form of Kelvin model. So when this Kelvin model is based on the parallel, Kelvin model is being used for the solid, but the Maxwell model is mostly used for the liquid, depending upon this property. And again, when you can extend this basic model and you can make more combination, maybe 2 day spot, 3 day spot, 2 spring, 3 day spring, in the series, in the parallel, in the mixed type, you can find out the different type of model. See, some of the models which where sir? This no. It is depending upon the nature of the geometry. If it is suppose it is channel, then we are using the Cartesian coordinate system, because in the two-dimensional Cartesian coordinate system polar, in the three-dimensional system three Cartesian, cylindrical, spherical. So depending upon if suppose this is the glass, it is cylindrical in nature, so we have to take the cylindrical coordinate system. If suppose if the channel is there like water flow in the river, so we have to take the Cartesian coordinate system. So depending upon the nature, if the pipe then cylindrical, and when suppose the circular shape is there, and we have to analyze the fluid flowing over the circular shape. So this is the spherical coordinate. So you can see the various model and you can work. So that's why the fluid mechanics people they are publishing many papers, because they have many options. You can choose one force, you can choose one boundary condition, you can choose one fluid model, you can choose one geometry and come with a new model. So there are various, when you have the option, you can, but still the paper when you will work on the basic problem which is more applicable, that will have more impact. So you try to model with very basic, then one again time dependent, like only two models are available. One is the geopactic and another is the isotopic. So, rheopactic, rheopactic and the thixotropic, you can see that it is depending upon the viscosity. When this viscosity is decreasing with respect to increment in time or increasing the time, and the second case viscosity is increasing with increasing the time. So both category you can define with the rheopactic and the thixotropic. So only two models are available in the time dependent non-Newtonian fluids. And you can also work, very few people are working on these two models because it is very complicated to use in the momentum equation. That's why you can see some other type of models also. Mathematical formulation I have not taken, but you can work on this fluid model, which are frequently used for the industrial fluid and as well as the biofluid dynamics also. So these are the some fluid model you can see, and very much important nanofluid. Most of the people are working now nanoscience, nanomaterial, nanotechnology, okay, and the nanofluid. And now people are working hybrid nanofluid and the tetra hybrid, tertiary, so depending upon the number, like Boolean algebra, and based on that you can define the fluid nomenclature. So when you are mixing one nanoparticle in the base fluid, two nanoparticle, three nanoparticle, okay, and you can give the different type of nomenclature for the fluid. But the basic concept behind that is the nanofluid, where base fluid you can consider as the water, as the oil, as the acetone, and the nanoparticle, metallic nanoparticle, metal oxide nanoparticle, carbon materials, metal nitride, metal carbides. So many types of nanoparticles are available, and the people are doing experimental work. You can take the data and use those data in your mathematical model. So that will be the good work on this field also. Then you can see the some non-dimensional numbers which are very important in the fluid dynamics, and based on the non-dimensional numbers you can define many physical phenomena. Like one of the case I have taken as a Reynolds number, you can define the nature of the flow. One of the case we have taken as a Mach number, you can define the different type of flow in the aerodynamics, and then you can take other type of numbers. Why we are using these numbers, and why, what are the role of the scaling? See, scaling always we are doing for our comfort zone and the scaling process. Even in the data, when we are doing some experiment, we have some chart, and we are doing the scaling like for 100 meter we can use 1 ml or 1 centimeter. So such type of scaling we are doing. So this scaling is known as the geometrical scaling, and we can show the complete merit in one A4 sheet. So how we are showing? Only due to the scaling, like 1 kilometer we are considering as a 1 centimeter, 1 millimeter, and plotting the complete graph for the merit and the showing. So that is the scaling. Same thing we are doing in the fluid dynamics. All physical quantities we scaled with the same dimension. Dimension in the physical quantity means what? Like a force is having the dimension. What type of dimension? In MKS system, you can use as a Newton, okay, and you can divide the same force, like one of the force, suppose inertia force is there. You can divide with the viscous force, gravitational force. The result will be non-dimensional. Dimension will be zero. So dimensional homogeneity, all type of physical equation or physical principle or whatever the law in the physics, you can see that every term is having the dimension, and that dimension should be same. Like if x plus y plus z plus whatever terms are there in the one equation, the dimension of x should be equal to dimension of y, should be equal to dimension of z, then that equation will be the physical equation. When you making the scaling with the same dimension, and if the physical quantities are transformed in the form of variables, then that will be in the form of mathematical equation. And then you can use any and all parameters, physical parameters will be like our independent and dependent variable x, y, z. And then as a mathematics people, we need this. So what we are doing when the set of governing equations are there, our first focus is we use similarity transformation, we use the scaling process, we do the dimensional analysis and find out the physical equation in the form of you can find out such type of transformation. So when we use the transformation, when we do the simplification, I can give one best example of the finite element approach. How to find the area of the circle, what we are doing. Because we know the area of triangle, we know the area of rectangular, we know the area of square, but how to find the area of circle? What we are doing? We are making the triangle. Yes, we are dividing the whole circle in the form of triangle, small triangle, and we find that area for one triangle and then multiply or take the sum of all the triangles. Okay, so what is the single triangle? That is the element, and that is the concept of the finite element method. But who has developed finite element method? You know, mechanical engineer, not the mathematics. So people who are working in the mechanical engineering, they started the FEM approach to do the simulation for 1D problem, 2D problem, and the 3D problem. And what they have used same concept which are there in the mathematics to find out the area of the various curve. So same thing when you think about how we making the element, because one is the continuous process and another is the discretization. So continuous process, when we are take in the different type of summation, that will be like integration to summation, differentiation to difference. Same thing we are doing, and the same technique we are using in the numerical approach, like finite difference. So what is the finite difference? Derivative, continuous process to discretization, like integration in the form of summation. So same thing we are doing in the numerical technique, and here also we are working for the different problem, and see that some principle, basic principle, as I told, in all type of analysis, flow analysis, we use this type of conservation principle. And conservation principle means what? What type of input you are giving, then same input or same amount of output you are receiving. So when you are receiving the same, whether it is mass or momentum or energy or concentration, nanoparticle fraction is nothing but it is the concentration of the nanoparticle. Because most of the students are confused. What is the nanoparticle fraction? Nanoparticle fraction, why we are giving this name different from the concentration? Because in nanoparticle and nanofluid, both analysis we are doing same. So considering the concentration of the solute and the solvent, we are giving two different name. One is for concentration and another is the nanoparticle, and then concentration of the electric charge. Like this concept you can use in the electrokinetic theory, that is behind that is based on the chemistry, and see the principle. This is the simple principle, and this should know. This is the continuity equation based on the mass conservation, and next is this is the momentum equation based on the momentum conservation. This is also known as the Navier-Stokes equation, and you know that still this equation is not solved. Still, if you can solve analytically, then you will get, I think, not Nobel Prize you can avail or field prize you can get. So this is again, most of the people we are working, you can find out, million, trillion models, mathematical model on this momentum equation, Navier-Stokes equation. But still, people are only taking some approximation, assumptions, simplifying the equation, and then solving. But you can think how we can solve. Nothing is possible, but you have to work on this. This is the energy conservation, energy equation. So I am not going much detail. And then the concept of the biofluid dynamics or biofluid mechanics will come in the picture. Like when you do the dynamics, when you do the statics in the biological system or biological phenomena, like the physics of the biological system or dynamics of the biological system, that is known as biofluid dynamics. And now you can find everywhere you just use the bio, that will be the new discipline of the research. Whether it is biomathematics, biochemistry, biophysics, biotechnology, or whatever subject you use bio. And you will come with the new discipline. So this biostatics is, and then these are the system, very important system, starting from the circulatory system, digestive system, urinary system. In last lecture, if you heard, I think this all system I have explained, and you are also aware. But most of the cases, you see the fluid is moving. So when the fluid or biofluid, you can consider in the different object, you can find out the fluid dynamics of such type of physiological system, and then you find out the different type of characteristics of biofluid, what type of flow pattern, pressure gradient, wall shear stress. So all these things we have discussed in the fluid dynamics. That means when you have the concept of the fluid dynamics, you can easily apply fluid dynamics for the biological system. And when you apply the biological system, only you have to consider that what type of flow regime or what type of process, what type of mechanism, what type of phenomena are there in the biological system. So when you have the concept, not complete concept, but at least what you need in your problem, if you have that concept, you can easily apply the concept of fluid dynamics for the biological system, and that is the new model for this. So these all are the, you can see some animation, which is very interesting, like how these systems are. Always you see the animation, because video is giving much clear concept as compared to the theoretical concept. Okay, and you can find out what type of mechanisms are there in the body, and how we can see the what is the role of the fluid dynamics, what is the role of mathematics, and what is the role of definitely AI and ML, which you are learning in this workshop. So this is the complete system, and then again the digestive system, and this is the respiratory system. What type of mechanism? All these flows are the internal flows. All flows are internal, nothing is external. And all flows are natural flow. Nothing is the force driven flow. Because no force we are giving. But if you know the mix up of both, if suppose the natural machine will not work, then how much pressure is required, how much force is generated due to the natural mechanism. If you can calculate same amount of force or same amount of pressure, if you can provide externally, that system will work. So that is our thinking process. And one of the best example I can give you, that is the microfluidic device, and you all are aware. And still now people are, if the patient is very serious, or a severe case is there, or COVID time, if you recall COVID time, most of the people, they are recommended for the ventilator. So what ventilator is doing? That ventilator is maintaining the oxygen level. Because if there is a problem in the lungs, or if there is a issue in the respiratory system, or due to some other problem disease also, if you are not able to take proper breathe, so what ventilator is doing? Just maintaining the oxygen level. Because we know that जैसे ही ऑक्सीजन रुक जाएगा, जीवन चला जाएगा, चाहे पूरा शरीर हमारा काम करता रहे, ठीक है? So we have to see that whether the oxygen level is high or low and how we control. So what is ventilator? Ventilator is an external device. It is not fitted in our body. But if there is a problem and we know that how much oxygen is required for a person to survive, then we can produce the external forces so that lung will work, and the same thing is happening during the attack. You know, if there is a problem in the heart is not properly pumping, so what we are giving? We are pump so that this heart will start working. Okay, so that is the external forces. If the natural pump will not work, how much pumping is required, we can externally give. So internally, these pumping processes are known as heart pump, lungs. In the lungs, there are different type of membranes, and the membranes are having the pumping process. And in the esophageal, they are also having a one type of pumping process that is known as a peristalsis. Peristalsis means muscle contraction and relaxation. So if all such type of concept when you know, then you can easily define the different type of geometry. You can see geometry. See all type of one animation you can see. This is the esophagus and how the food bolus is trapped in the single bolus and moving in very controlled manner. Based on that, we have defined. We know the wave propagation. We know the periodic function. How we can make such type of wave propagation with the mathematical function, we can easily do. This is one bolus. Suppose two bolus are there, we can do. If it is three bolus, we can also do. If it is n bolus, we can also. So this is the beauty of the mathematics. But how it will come? When you can think in that way. So when you think the biological process, which is very natural, how we can make the artificial esophagus in same way. So you have to study the material property because that material should work. But as a mathematics people, we should do the analysis, mathematical analysis, like how much expansion is required, how much relaxation is required, how much pressure is required, and what will be the maximal tensile rate of that material. Sometimes, if suppose expansion is there, but that material will break. Okay, so all such analysis, if you can do, you can produce the mathematical data to the particular person who are working experimentally. They can think the external artificial, external kidney, external lungs, external heart, okay, and other part like intestine also. Because now the people, many people are having a kidney problem and sodium and the potassium level, and the doctors are not easily diagnose this. That if your sodium level is very low, you people are thinking that it is might be the case of heart attack, and they are not thinking that maybe the case of low potassium or low sodium. And in between, understanding these things, whether the case of heart attack or the case of the sodium and the potassium level, the treatment will take time, and again you see what is happening. So same thing when we have the micro level chips or micro level devices that can externally fit it certain, and at least the first aid can be given at the very initial level. अगर हमारे हर घर में छोटा छोटा फर्स्ट एड से कट जाता है तो हम कुछ लगा के दवा और बांध देते हैं, तो उस तरह से अगर इस तरह का भी जैसे हार्ट अटैक का केस हुआ, सोडियम का केस हुआ, इस तरह का भी हो केस, and when we have the small level microfluidics devices, we can just put and make some first aid, and at least we can transfer that patient to the hospital. So we can think about such type of biological phenomena. Then these are the mathematical equation, and see all these mathematical equation when you put in the MATLAB code or Mathematica code, the previous slide animation you can find out. And see, when we have the mathematical expression, we can play with the mathematical parameter and variables. This is the advantage. आप कुछ भी वैल्यू देते रहो, different type of shape मिलेगा, different type of pattern मिलेगा, different type. अब इतनी flexibility है कि आप सुबह से बैठ के केवल MATLAB कोड पे बैठ के जो है बस देखते रहो कि x की वैल्यू इधर से उधर कर रहे हैं, उधर से इधर कर रहे हैं, कितना अच्छा अच्छा नजारा दिख रहा है, ठीक है? And then sometimes वो जैसे न्यूटन ने जो है बस बैठ के देखा और निकाल दिया, वैसे आप भी हो सकता है कि कोई ऐसी चीज मिल गई, ऐसा नहीं है कि सबके साथ मिलेगा. वो तो you can see now huge after 200 years एक बालक 19 साल का जो है वो जैसे हम रिवर्स काउंटिंग पढ़ते हैं, उसने रिवर्स जो है मंत्रा 50 lakhs मंत्रा जो है एक साथ पढ़ गया. इट इज नॉट इजी. हमें सीधा मंत्र याद करने में कितना टाइम लग जाता है और उल्टा मंत्र याद करने में सोचिए, जैसे हम काउंटिंग पढ़ते हैं और रिवर्स काउंटिंग पढ़ते हैं, तो जब आप ऐसे प्ले करेंगे तो कभी कभी ऐसा समय आ जाता है कि मान लो 100 बच्चे बैठे हैं और किसी ने एक अच्छा ज्योमेट्री या मैथमेटिकल फंक्शन फॉर्मुलेट कर दिया जिससे कि हमारा पूरा एसोफेगियल सिस्टम या डाइजेस्टिव सिस्टम या रेस्पिरेटरी सिस्टम कंप्लीट उसी तरह वर्क कर रहा है. और अगर कंप्लीट वर्क करना शुरू कर दिया, यू कैन फाइंड आउट वेरी गुड some animation and the function. This is for the respiratory system, propagative membrane and the non-propagative membrane. And now by most of the students they are working to develop the different type of function, to find out the different type of membranes. It is not only applicable for the biological system, but it is applicable for the filtration and the mixing of the sample and the mixing of the chemicals in the chemical industries. And also if the chemicals are very costly and you need to mix very small amount micro or nano level of chemical and you want to find out some new results, so micro pump you can develop and with some membranes you fit and see again the beauty of the mathematics, like one membrane we have fitted with this function, but you can go for n number of depending upon the requirement कि हमें कितना जो मेम्ब्रेन की जरूरत है, हमें कहाँ जरूरत है, किस पोजीशन में जरूरत है, that you can make it. So one of the like two membrane, but you can go n number. क्योंकि ये क्या है, simple summation है and the mathematics people can do only. So when you can think and this propagation also you can see this is the propagative propagation because it is vertical as well as horizontal. So it will work like a respiratory system when you see the animation of the respiratory sea. This is propagation. It is not actual, but like that. But you can work, then you can make more by and see the animation. This animation you can compare with this type of animation. And this is the material property like roughness property, other type of properties you can make in the mathematical equation. So these animations are very important. Now we have started working on the tumor. Like different type of tumors are there in the body and how they are obstructing the flow analysis. One case is the tumor is growing and blocking the complete flow designs or vessels, okay, and due to that the severe pain is coming. क्योंकि ऐसा नहीं है कि उसके बढ़ने से केवल पेन होता है, पेन कब होता है जब हमारा नेचुरल जो मैकेनिज्म है वो डिस्टर्ब होता है, ठीक है? जैसे हम खाना खा रहे हैं, खाना अंदर नीचे न जाए तो यहाँ पे बहुत ज्यादा पेन होगा, ठीक है? उसी तरह अगर डाइजेशन अगर प्रॉपर नहीं हो तो हमें प्रॉब्लम होता है. तो जहाँ जहाँ जो है फ्लो ट्रांसपोर्ट का प्रॉब्लम होगा, ब्लॉकेज होगा, then we can. So generally the tumors are classified in two forms. ठीक है, अब हमें ट्यूमर की पूरी बायोलॉजिकल प्रॉपर्टी कर सकते हैं, अगर आप करना चाहें तो बहुत कुछ कर सकते हैं, बट अगर उतने लेवल तक नहीं भी जा सकते हैं, तो यू जस्ट सी दैट व्हाट इज द ट्यूमर शेप and how it is growing, and what is the classification of the tumor, how it works, and what is the phenomena or mechanism behind that. So these are the phenomena for benign tumor, which is the non-dangerous. एक तरह से बस केवल सेल की तरह रहता है, ब्लॉकेज बस बनाता है, इसको आप चाहेंगे तो ऑपरेट करके बाहर निकाल सकते हैं. That's why it is known as non-cancerous tumor, and this is the cancerous tumor. Now you compare the geometry of both the tumors. One is the elliptical or circular. यहाँ पे elliptical है, हो सकता है circular भी shape आप देख सकते हैं. यहाँ पे जो है आप देखिए shape. Can you identify what is the shape? And in this case there is no much growth, but in this case there is a huge growth, and you can find out after some times one tumor can take n number of tumors. Okay, in such a way. So till now we are able to see the tumor growth linearly, quadratic, non-linearly, and exponentially. But वो हमारा शेप कहाँ से छोटा से लेके बड़ा तक जा रहा है, यहाँ तक तो हम लोग कर लिए हैं, लेकिन हम आपके लिए कह रहे हैं कि if you can do one shape can be broken in n number of the shape, so we can do more better analysis in the case of tumor. So see our analysis, like one case we have taken one shape and how this flow is disturbing with the obstructed by this tumor, and the second case you can see that this tumor is increasing and disturbing the flow pattern. So this analysis we have done in the our research work, and that such a simulation you can do it, and the same thing you can do with the AI technique also. So you can see this simulation, and after that I think overview of the AI. Most of the people have talked about AI, ML, and this, but this is a very systematic definition, because I am also learning. I am not very much expert. If you ask any question about biofluid, fluid mechanics, numerical technique, differential equation, PD, I can. But AI I am also learning, and the same thing I was discussing, because a lot of confusions are there. That's why I am not very much confident. But I have given some problem to my student, and then with their presentation I will also learn many things. So these are the definition. I think most of the good experts, they have delivered their talk on this. Only the main focus, you can use some application I have related, but I don't think to read all those things. But how we can think, but you can find in this PPT everything very clearly. What are the function, and then flow prediction. These are the methodology. I am not going in detail. This is again how to define the different type weights, base, and how we can calculate, and then we can find out the different neurons, spectron, and out layer, hidden layer, input layer, many layers. Okay, and you can find out, and this finally you are predicting with this function. So these are the functions which you are using, and find sigmoid and tan hyperbolic and rectified linear unit. So these are the important. I will just come to my field, which these are the basic things which you can understand if you read. These all are the concept of the Boolean algebra. If you have good concept of the Boolean algebra, you can do it. I'm also learning with the concept because I'm teaching the discrete mathematics. So I'm trying to relate with the graph theory and this Boolean algebra also. So these all layers you can find out. I will come. See, I have related, but I cannot go much detail. I think time is almost over. So I just wanted to show this relation. See, all my work I have related to this analysis. Mainly, I come to this problem. These are the tools, opportunity that you can do it. See, this is the problem, biological problem which we have taken, not biological, this is the fluid dynamic problem. This is one surface stretching sheet where the boundary layer theory we have applied, and in the bottom we have used the surface is negatively charged, and the liquid or fluid is electrolyte solution. How this electrolyte solution is moving over the stretching sheet, and one of the non-Newtonian fluid model we have used in the micropolar fluid this case, and these are the governing equation. This is just like a partial differential equation, and now you can do the scaling and similarity transformation and come to this ODE form from the set of similarity transformation. This is basically what we are doing. The set of TD we can convert into the set of ODs. So when we have the set of ODs with the boundary condition, in the bottom you can find out the boundary condition, what lengthy boundary condition the students are now doing. Okay, and then these are the physical parameter quantity. You can define skin infection and rate of heat transfer or the Nusselt number. So these numbers you can define, and then this is the one numerical technique. Most of the people now they are using boundary value problem, that is B, or C. I think 5C also come in the new MATLAB. So most of the, so what is this solver, MATLAB solver? Inbuilt Range-Kutta method, and another method is Tooting method. So what is the role of Tooting method? Boundary value problem you can transform into the initial value problem with the Tooting method. So what? See, same thing we are discussing. This method I am confident because I know what is the role of Tooting method, and after converting the boundary value problem in the initial value problem, one boundary value problem can be converted into the n number of initial value problem depending upon the order and nature of the differential equation. And when you have the initial value problem, then you can use the Range-Kutta method, Euler method, Euler modified method. But in this inbuilt solver, Range-Kutta method is RK fourth order method is inbuilt. So both methods are together written as the code, and this solver has been prepared. So students they are not aware about the algorithm behind this method. They just go through the, this is the solver, they are using the governing equation and solving the. So when you know, and you can also verify, you solve any equation with Tooting method and the RK method, and then you compare your result with this solver, you will find same result. So that's why you can use this solver and find out, and the same problem you can use the ANN. This is also code, and this is a inbuilt code. But I am not very confident that what type of mechanism behind this. But results are coming. Results are coming, and many students they are working on this type of technique, and they are using that by using ANN. Our solution is a good, but I didn't see any accuracy comes when we are solving the same problem by using a numerical technique. But maybe after some times it will improve because it is the starting. So day by day the improvement will come. So this is the step. What steps they are using in the MATLAB or Mathematica code, and they are using these steps and finding this all these steps are there, and finally they are using this step directly in the code. The whatever the results are coming, this is again in the form of the system of equation, and this system of equation when you can solve, this is the complete process, and the result is coming like that. This is the comparison between the numerical simulation and the ANN prediction. But what type of predictions are coming? When I am asking with the student, they are not able to answer because both are the simulation. Nothing is prediction. But they are telling that it is a prediction. Prediction means something you can predict which cannot be found. Okay? Because prediction is always future. And analysis is our present. As per my understanding, I am trying and hope next year when I will come, I will be able to explain all those things I am learning. So I am not able to tell anything much about this, but students are doing and they are getting much better solution. You see, there is no change. If you see the this solution and this solution, both are very same. And the code are different. I have checked the codes also. Sometimes students are very smart. Same result, same code they are using and putting different. Sir, I have solved by using this method, that method, this method, and the results are coming this. That's why I am personally checking the code. They have used different code, but I don't know how they are finding this accuracy in the both the simulation and the UC find the beautiful results. So these results are for various simulation. They are using. So you people can also, as a pure mathematics, I think you should work how to solve the differential equation, because I have listened many talk who are working on the AI and ML and solving the OD, first order, second order, but still they after some times they are using the same process and from the software they are able to solve. But like a numerical technique, when we are using suppose finite difference, at least we have some solution, some expressions are coming. So we are confident that at least some solution. So we can work on this together and we can find out some results. So these are the some tables, and I think this is just a motivation where you can use AI ML, new techniques also you can use and learn, because learning is the best option for this profession. If you are going for teaching or for faculty position, क्योंकि टीचर ही एक ऐसा बंदा है, समाज का एक ऐसी जाति है जो हमेशा पढ़ता है. बाकी बाकी कोई प्रजाति ऐसी नहीं पाई जाती है. तो टीचर ही है जो मतलब मरते दम तक, अगर मुझे लगता है कि अगर आप शमशान में भी उसको कह दिया जाए, चांस दे दिया जाए कि भाई एक लेक्चर ले लो, तो ले लेगा. ठीक है, तो इतनी टेंडेंसी हो जाती है. तो थैंक यू वेरी मच. If you have any question related to the fluid dynamics, related to the research, biofluid dynamics, numerical technique, or any approach how you proceed in your research, I will be happy to share, because you all are students, so I will always be happy to share my experience, what I have learned from last 15 to 20 years in my research career. No, when we are using this inclination, like when we are, so from the glass, water is coming to mouth. This is the force. But from mouth to stomach, this is the nature. So these two parts you have to consider. Like when I am drinking, means we are using the gravitational force. We are inclining the gravitational force. So when gravitational force is inclined, then water is moving. So from this glass to mouth, it is a pressure driven force. But after mouth, it is the nature. Any other? No. Thank you. Thank you very much.
Thank you, sir. On behalf of organizing committee, I extend my heartfelt gratitude to Dr. Dharmendra Tripathi for delivering an insightful and thought-provoking talk. your session on fluid and biofluid dynamics, integrating AI, machine learning, and mathematical frameworks provided an excellent overview of physics-based fluid modeling integrated with modern AI and ML approaches. Sir, we are truly grateful for your valuable time and contribution to our 5 days international workshop on AI. Thank you once again, sir. Now, we would like to honor Dr. Dharmen Tripathi sir with a token of appreciation on a gesture of our gratitude. I would like to request our HOD sir. We will assemble tomorrow at 9 a.m.
Recording